This conference will now be recorded.
Well, since I hope everyone is here and we have lot to cover, we really should begin today's webinar. I really appreciate you all for attending today's webinar. A very good morning, afternoon, evening to one and all present here virtually with me today. Let me introduce myself. My name is Rachel McLean, Conference Secretary at Coalesce Research Group LLC, and I will be available for any of your queries or questions throughout the webinar to help you out technically and organize the webinar successfully. I would like to thank the attendees of the participants of today's webinar and hope you enjoy the webinar and gain knowledge from the sessions today. We also hope your participation will contribute to the new research findings and that will lead to the new collaborations and research innovatives. Before we start with the sessions, I guess some of you will be the new to GoToMeetings app. Let me just explain you the important tools required for the presentation. On the GoToMeetings app or web page, you can find four icons at the bottom center: mic, camera, screen, and or leave. Mic button. Click on that to mute or unmute yourself. I request you all to stay muted while our speakers are presenting their research work so that it does not cause any disturbance to them. Camera button. You can use this button to share or unshare the web camera. If you have options to share the webcam, you can do it, or it's completely your choice. Screen button. You can use this button to share your screen. This is the main part during your presentation. After I call your name from my side, I will be making you as a presenter and only I can give the permission you will be able to share your screen. So once I make you the presenter, you can click on the screen button and you will find a pop-up window to share your screen. End or leave button. This is your fourth icon where you can use this to leave the session. On the top center, you can use the options to change your display settings. At the top right corner, you will be having three icons: people, chat, and settings. In the chat option, you can chat with me or any other participants. For the settings, you can use this button to check for the settings of your speakers and microphones. As I mentioned, kindly remain muted during the presentation so that the presenters do not get disturbed. And for any questions, you can ask the questions or you can send your question in the message box too. Well, let's not to take much of your time. Finally, I would like to thank you to request you to please give us a brief introduction about yourself before starting with the sessions so that we can know about your virtually. And now let's move into our sessions. Our first presenter is Dr. Farhan Julfir from Northeast Forestry University, China. Doctor, are you ready with your presentation? Dr. Farah, Dr. Julfikar, can you hear me? Please unmute your mic so that we can hear you.
Hello.
Yes, we can hear you. Now I'm going to make you as a presenter now. Please share your screen. Dr. Julfikar, please share your screen for the presentation.
I am trying to hear.
Hello.
I am trying to share it.
You need to click on that screen share button. Share screen.
Not working on phone.
You can find that icon in the bottom of your GoToMeetings app. It's the third icon you'll be having screen. Please click on that screen button.
Still, this is on my phone. That's why there is trouble. Mm,
Are you able to share your
Please
screen?
not. No, there is no option of sharing.
On the GoToMeetings app, you can find four icons at the bottom center. One is
There
for
is
mic,
one
one is
for
for
video.
camera,
Yes.
one is for screen. You need to click on that screen button to share your presentation. Yes, now we can see your screen. Please share your presentation.
Now can you see?
Yes, we can see that. Please make it as a full screen. You can.
Wait, I try to on my laptop.
Okay.
Did I this work on my laptop?
Mm, wait. Okay. You have joined in the laptop, right? Okay. Which one I have to made you as a present? In phone or your laptop? I think you need to click on that play button so that we can see it full screen. Doctor, are you able to share your screen? We can see your screen, but you need to click on the presentation. Doctor, can you hear me? Please respond. Dr. Julfikar, please respond. We can't hear your voice. Now we can see your presentation. Please make it as a full screen so that everyone can. Please click on that slideshow button. Dr. Julfikar, please respond. We are unable to hear your voice. Please unmute that mic button so that we can able to hear your voice. Dr. Julfikar, please leave the meeting and rejoin in that. I think Dr. Julfikar having some technical issue. In the meanwhile, we can start with another presentation by Dr. Daria Ferres from the Clitorius Research and Development, Poland.
Can you listen me now?
Yes.
Can I start?
Okay, please start.
Okay, I am PhD scholar in Northeast Forestry University, Harbin, China, and my research paper is on analysis and influence factors on household income and food security in Pakistan. First is the introduction. Household income refers to the collective income of all the people living in of a household, and these members must be having age of 15 years or above. To be considered the members of a single household, the members whose collective income is being considered do not need to be related to each other in one way or the other. The living standard of a particular country or a region may be evaluated and analyzed based on this parameter, household income. There is another factor that may be considered as an evaluation criterion of our living standards, and that factor is called food security. The term urban agriculture can be defined as the production, processing, and delivery of food to the cities as well as towns that cover most of the urban and pre-urban area by applying various procedures for farming or production of food through the use of natural resources as well as waste from the urban areas. Livestock is a very important component of our overall agriculture, and it involves various domestic animals that are raised and fed at a particular agriculture places, and the purpose of livestock is to produce various commodities such as eggs, milk, meat, etc. The animals that are included in the livestock such as goats, buffalo, sheep, horses, etc. depend upon the country whose livestock is being considered. Another important aspect that is a part of this study and is somehow related to the agriculture and economic conditions of a country is urban sprawl. Urban sprawl may be considered a form of urbanization, the movement of a people from more populated areas of a country to the areas where there is very little population. Thus, a new residential area is developed on rural land. And the hypothesis which is developed in my research paper is hypothesis number one is urban agriculture has a significant impact on household income in Pakistan. Number second, peri-urban agriculture has a significant impact on household income in Pakistan. And third is livestock has a significant impact on household income in Pakistan. Urban supply has a significant impact on household income in Pakistan. Urban agriculture has a significant impact on food security in Pakistan. Urban agriculture has a significant impact on food security in Pakistan. The livestock has a significant impact on food security in Pakistan. And urban sprawl has a significant impact on food security in Pakistan. This is a research framework in urban agriculture, pre-urban agriculture, livestock, and urban sprawl. These are the dependent variables, and household income and food security is the independent variable. And there is a one control variable that is the population growth, which have an impact on household income and food security. Methodology data collection is based on the previous year's performance and from the authentic website related where authentic data is present for this kind of study. Most of the time is the secondary data is preferred to be inserted for analysis. Here the researchers selected and collected the data from the past 22 years that range from 1998 to the year 2019 for Pakistan. The data was collected from the food and the agriculture sector and also from the statistic department of Pakistan related to the field selected. Model in this empirical analysis has been used to explore the impacts of urban, pre-urban livestock and urban sprawl on the household income and food security in Pakistan by developing VR vector auto regressions and VECM vector error correction models. Results and discussions. The statistics explore the relationship between dependent and independent variables. The study employed VR and VECM model. The empirical results of the various decomposition of the household income indicate that the urban agriculture caused significant changes in household income in 10 years as the values have increased from 0.90 to 33.95. However, the contribution of urban agriculture in the fluctuation of household income remains constant. Moreover, the variance of urban sprawl also increased significantly in the first 3 years, then the decrease and ended up at 36.4 in the 10th year. Besides, the variance decomposition of food security indicate that it is influenced by the pre-urban agriculture practices, livestock and urban sprawl. The fluctuation in food security due to the livestock and urban sprawl increased from 2.9 to 33.5 and 18.0 to 2.25.0 in 10 years respectively. Research implementation. The study has researched the linkage of urban and pre-urban agriculture, livestock and urban farm with the household income and food security by using VR and co-integration model. However, the study is still not devoid of some limitation. First, the scope of research is limited for Pakistan. It may only extend it into developing economies. Second, the study has only applied in time series data, and there is a possibility that results may be biased toward the statistical techniques. Third, only one control variable, population growth, is used to check the sensitivity of results. Despite these limitations, the study has substantial implications for future research. Future studies may be implied some theoretical framework on the panel data of developing countries. Also, the comparison between developing and developed countries is conducted based on this theoretical model. Besides, the indirect linkage between dependent and independent variables may be explored by introducing some mediating or moderating variables. Thank you very much. Mm.
Thank you, Dr. Farhan Zulfir, for your presentation. Is anyone having any questions? I think there are no questions. Let's move to our next presentation by Dr. Daria from Coalesce Research and Development, Poland. Doctor, are you ready with your presentation?
Yes, I am. Just let
Okay, now
me.
I'm going to make you as a presenter now. Please share your screen.
All right.
Okay.
So I guess you can see my screen right now.
Yes, I can. Please continue with your talk.
All right. Thank you very much. Uh, Good morning, good afternoon, good evening, depending on what location you are currently. Thanks for this opportunity to present you Clariter technology and how sustainability boosted innovation in chemical science that we ended up with this technology. Uh, I would like to start with the conditions of being successful in the science. I read this very interesting article, and it was that is cited in the bottom of the slide. And actually, it was pointed out that there are four major requirements to be that needs to be fulfilled to be successful in science. So first of all is the knowledge. Actually, it is easy to understand that we need to know what we are doing. We need to have a knowledge that is basis for our future research. Uh, we cannot just jump into the science from the street, right? So the knowledge, of course, is very important. We also need some technical skills, especially in chemical science, when you need to run some tests, run some reactions. It requires your technical abilities to be really on a high level. Also, communication is important because we can see it in our labs and run our research, but if we cannot share it with the world, if we cannot tell others what we have found out, uh, somehow it is useless because it won't be further taken further. That's why communication is also very important. But actually, the key for the success is creativity. Uh, of course, there are many problems in the world and there are many ideas how to solve them. But if you are not a creative scientist, if you don't think out of the box, you won't be innovative. And I think this creativity is, and it was also written in this article that this creativity is a key for success. So also in the same article, there was a list of ideas how to be creative, and there was one that I liked really the most. Um, it is to follow the rule that where's the smoke, there's a fire. Just to explain you a little bit, so if we look for an inspiration, if we look for new ideas or new solutions, we should look around what is happening in the world, in the science, if there are any discussions, is there any new research which is kind of controversial. So if there is some kind of, let's say, noise around some topic, most probably there is something interesting in it that we can look for inspiration and ideas how to what to do, what to work on, and where to look for the new concepts. So what was the smoke in terms of Clariter and the research that was basis for Clariter technology? Uh, I, I think I don't have to ensure you, and I guess that you as a scientist that are here in this webinar, you understand the current issues that our society is facing. Actually, our Earth is facing, and that one of the this biggest issue is global warming. And for me, it was quite interesting to find out that the 19 hottest years have occurred since 2000. So this is the solid data. So this is one of the things that creates, let's say, the smoke, and that we should reduce the global warming. We should reduce the CO2 emissions, and it is already interesting, and we know that many things happens around, including also regulatory things, but also for us as a scientist, this is also something interesting, how we can approach this issue, how we can enter this smoke. Another one is the plastic pollution. And again, quite interesting assumption from Ellen MacArthur Foundation is that by 2050 there will be more plastic in the ocean than fish, which sounds actually personally for me terrifying. And we hear also about microplastic issues that we are not currently sure what is the risk related to that. But even the fact that there is a lot of plastic that is all over the world, it creates an issue. It is something, let's say, inspiring in research to find solutions for this issue. So actually, the plastic itself is not an issue. We know that it's wonderful material, right? It is very light. It is very cheap comparing to other alternatives. It's durable. It has many beautiful applications. But so the plastic itself is not an issue. The issue is the plastic waste. I would like to refer to situation in Europe because I guess it won't be too big exaggeration of my assumption that if I assume that Europe is quite advanced in dealing with the waste. So in Europe, yearly we collect almost 30 million tons of post-consumer waste per year. Then this waste is sorted out. And it's quite interesting that even in Europe, that where there is a lot of regulatory efforts to force society to make recycling, still only roughly 20% of the sorted out stream is recycled and used as a recyclate in new plastic items. Still, majority of the collected plastic waste is incinerated. So we are still releasing the CO2 to the environment, and also a big amount, which is actually much bigger than recycling, is landfill. And again, there is the risk of this microplastic pollution, that we store the contaminated plastic in areas, and we don't know actually what to do afterwards. So uh, uh, all these factors are combined together, and I think it is really good starting point to think of what we can do with those issues and with those aspects. Actually, sustainability is not only to reduce plastic waste, not only to clean our planet, but we also should think further, like reduce the dependency on crude oil. Of course, in long perspective, I guess we can assume that in some point of time, crude will end up, right? We won't have any more crude in the world. But on the other hand, also using crude oil and extraction of crude oil has significant environmental impact. We should also empower local economies, because being sustainable is not only about environment, but also about society. So combining all of that, I think it is really good base for looking for new solutions and ideas. So what is the fire? Where is the key problem, or where is the key concept where we can look for innovations? So let's fast forward or maybe let's step back to see what's happening with plastic waste currently. Of course, what we want to do is we want to reduce the amount of plastic worldwide. Uh, and in some cases, it's not doable. Actually, I guess that COVID-19 pandemic showed us that plastic is not replaceable at this moment of time. We have plastic gloves, we have masks, we have wrapped food, which is protected. And as we care about our health and safety, at this moment of time, plastic has no real alternative, because paper you cannot disinfect. It won't prolong the shelf life of food for so long like plastic do. In some cases we can do it, and of course it should be done. That's why to reduce the amount of plastic is the most desirable way to move. But in many cases we cannot do that. The same with reuse. Can you imagine reuse of food wrapping? Can you imagine reuse of those single-use gloves that we use to protect ourselves currently? I guess you may have a feeling that that is not much doable. Looking on the opposite side, we have landfilling, which is of course not wanted solutions because of all the reasons I mentioned before. And energy recovery, it releases CO2. So it is also touching the first issue I mentioned in my presentation. So here in the middle, we have a recycling as a kind of intermediate solution between reduce, reuse, and energy recovery and landfilling. So currently, we have two types of recycling. One is mechanical plastic to plastic recycling, and one is chemical, or called in US advanced chemical recycling. What is mechanical recycling? It's quite simple. We have plastic products that are later on used by the user. Then we have the waste that is shredded, cleaned, mechanically recycled, remelted, mixed with proper modifiers, and at the end we have new items that can be used by users. The issue with mechanical recycling is that it has its own limitations, and we cannot run those circles to infinity, right? Because plastic reduces its mechanical properties due to reprocessing, and we need to add more and more these modifiers, and it has its own borders. Uh, let's look at the color. If we mix different colors at the end we get black material, and there is nothing more we can do with that. Now, chemical recycling or advanced recycling gives an alternative what we can do with plastic that was used by the users. So it is shredded, prepared, and then run through proper chemical process. So at the end, or we get new polymers that creates new plastic, or we get fuels. And here comes new issues. First of all, if we want to go through this route to get new polymers, in some cases it is doable to do that with high yields, for example, for PET. But for many other polymers, that actually the ones that are most commonly used in plastic packaging, like polyethylene, polypropylene, it's not possible to do that. Well, you can do that, but the yields are very, very low. The yields of new polymers you can get out of the waste plastic, it is roughly 30, 40% maybe, and all the rest is going to fuel. Now, making fuels out of these plastics is also doable, and actually in US still it is considered as a this advanced recycling. But in Europe, it's not the case, because in Europe, making fuels out of the plastic waste is not considered as a recycling according to Waste Framework Directive. It is energy recovery. Because if we think about it, at the end, we burn those fuels to create energy. So we again release CO2 to the environment. And so that's why according to European regulations, and also I think our feeling and understanding, it is somewhere lower in the hierarchy. So the innovation. So if these are the two issues, we have polymers that cannot be anymore mechanically recycled. We have polymers that can be recycled to polymers again, but with very low yields, or can be transferred to fuels, but then we have energy recovery. I think it is really good point to look for innovations. And this is what was done by Professor Andrzej Belicki. He was a very famous and great chemist in Polish chemist, and he ran his research in a lab scale. So at the end, in 2002, he applied for a patent. That was later on granted not only in Poland, but also in US, in Israel, and some other European jurisdictions. And in 2003, a company called Belicki Laboratories that was later on renamed to Clariter was created. Just for you to know, when Professor applied for the patent in 2002, he was 86 years old. So he was so visionary, because at that time no one was thinking about issue of plastic waste. In general, it was or landfilled or incinerated, but that time not many people cared about the future issues that is plastic waste pollution. Professor was a visionary. He knew that this will be an issue, looking on the lifetime of plastic, looking on increasing consumption of plastic, but also considering that the current solutions for plastic waste are not good enough. He knew that he has to look for new solutions, and this is what he did. That's why he applied for this patent. Again, that was granted. And in 2005, we as a company, we started to build our pilot plant. So from the bench lab scale, we scaled it up to pilot plant with capacity roughly about 6 kgs per hour. And that plant was privately sponsored. We may say that we built it up in 2006, but through all the years, it went through many modifications, because we run all the time R&D, trying to upgrade the professor's idea to fine tune all the details. And in those pictures, you can see how the shape of the plant changed over the years. We invested in that pilot plant because everything again was privately sponsored and was privately owned. We had a couple of reactors for hydro processes. We had a couple of reactors for thermal treatment of plastic waste. We had a couple of distillation columns. We have our own lab that is fully equipped with GCMS, GCFID, GC4 SIMDIST analysis, all many different analysis for physical chemical properties of hydrocarbon-based products was also implemented. But we also ran many cooperations with different universities, like Silesian University of Technology, Wrocław University of Technology, Warsaw University of Technology, a couple of research institutions. So it was really a lot of effort put to this research to find the proper solution for plastic waste. So, of course, the natural question following is, so what is the solution? What we do in Clariter, and it was exactly the idea of Professor, of course, over the years developed, we take those plastics that cannot be mechanically recycled anymore. All types of polyethylenes, we do accept some level of polystyrene, And we run it through a mix of processes, I would say. So first step is a thermal cracking. You can call it pyrolysis as well. In this process, long polymer chains are broken down to shorter chain hydrocarbons that are immediately and directly injected to hydrotreating section. So we use hydrogen to purify this mixture, to saturate olefins, to saturate aromatics, to remove sulfur, nitrogen, chlorine, whatever else is in there. So at the end, we separate it into 3 groups of products: solvents, oils, and waxes. Everything happens in one plant. It's not like we send some intermediates to the refinery, but we run it all in one boutique refinery that is owned by us, and that at the entrance you put the plastic waste, and at the end you get the final product. What is unique about our products is that these are high purity products. They are really fulfilling, for example, FDA purity standards. So potentially could be used in cosmetics. Those products are aliphatic solvents, paraffin waxes, and white oils, because we target the highest value and highest purity products out of plastic waste, because they have variety of applications. You can think of very simple applications like the greasers, or you can think of candles, but then you burn it. But there are also more advanced applications like inks, coatings, like wood treatment products, like wax emulsions for paper packaging, and many, many others. So we are taking plastics that nobody wants. Well, maybe incinerators would want to take it, but we don't want to give it to them because we don't want to increase the CO2 emissions. So we are taking the rejects from mechanical recycling and running through the process. So at the end, we are getting products that everybody needs, because you can find our products in such applications like shoe polish or car wax. Just imagine that you have electrical car and you want it to be shiny, nice and shiny. Then you use a car wax. Of course, you have car waxes that are based on natural waxes like beeswax or carnauba, but they will never have the same properties like hydrocarbon-based waxes. So we offer a real alternative for crude-based products that we are taking packaging, and we can make an ingredients into new products. So this is totally new approach that the company that is producing this kind of products can have recycled content in the packaging itself, because coming from mechanical recycling, but also recycled material inside the product. So this is like new path and new type of chemical recycling, that we don't make plastic to fuels, we don't make plastic to new plastic, we upcycle plastic to new high value pure products. Well, I really like this statement. Giorgio Parisi said, "It is clear that for the future generation we have to act now in a very fast way," and it's true. Since 2002, it took us a lot of time to be on the point that we are right now. You may say, well, actually, it's not so fast you would expect, but this is the nature of scaling up chemical processes. It's not easy. It's not IT that you can multiply simply the solution. You need to scale it up step by step. So the first step is a lab scale. Then we have a pilot. But we are running fast. We are really running fast, because we built a first industrial scale plant in South Africa in 2019, and it is kind of intermediate step as still, because it's demonstration plant. You may say, well, 1,000 ton per annum facility is very small. Actually, it's a small drop comparing to big petrochemical processes. That's true, but from chemical recycling point of view, it is already industrial. But this is not the last thing we do. For us, this plant is, as I said, kind of demonstration plant, but also training center and the base for scaling up for the final scale, which is 60,000 ton per annum per one facility. Again, from a refinery point of view, it's not huge, but from chemical recycling point of view and waste plastic management point of view, it's huge. So where we are right now, we have 6 families of patents. So starting from professor's patent, thanks to research that was done in pilot plant in Poland, we applied for 6 families of patents that are already granted in many jurisdictions. We invested actually almost 40 million euro in this research and development to mature the technology. What is interesting about our technology, we ran LC life cycle assessment, LCA, for the technology, which showed that we are carbon negative. We have net negative carbon footprint for our products, which is also addressing the first issue I mentioned at the beginning of the presentation. We also got a confirmation from European Chemical Agency that our products are real alternatives for existing products that are already registered under REACH in Europe. So these are real alternatives, just coming from the different source, not from crude, but from plastic waste. And then we are rolling out. As I mentioned, now our target is a much bigger facility. We are currently working at 3 projects in 3 locations parallelly, so we are really running fast. And I think the technology itself is still developed. For us, even if we build 3 facilities, full-scale facilities, we will continue to run R&D, because for us, it's continuous improvement is a never-ending story. The issue of plastic waste will not disappear in 1, 2, 3, or 5 years. Not even in 10 years, I guess. But let's assume that in the future we find very nice bio-based alternative for crude-based plastics. Still, we will have plastics that are in landfills. So Claritar technology, because it takes the lowest grade polyolefins, is also a solution for that issue. And this is it. This is how sustainability may boost and give you a really strong push to look for totally new solutions. As I said, in 2002, when Professor applied for the patent, there was not such a term like chemical recycling. Now it is quite new industry that is very fast growing, and it will grow. So thanks for your attention, and I hope I give you some inspirations.
Thank you, Dr. Zarya, for your presence and presentation. Is anyone having any questions? I think there are no questions. Let's move to our next presentation by Dr. Mohammad Farhan from the University of Hong Kong. But due to some emergency, he was unable to attend today's webinar, but he has provided his recorded video presentation. I'll be sharing that. If you have any queries, you can mail to the Consent Program Manager. They'll respond. Otherwise, I think we are having some technical issue. Let's move to our next presentation by Dr. Nahid Aziz from Tehran University of Medical Sciences, Iran. Doctor, are you ready with your presentation? Dr. Nahid.
Hello, everybody. Yes, I can present
Okay,
my,
now I'm making you as a presenter now. Please share your screen for the presentation.
of course. Can you see my screen?
Yes, please make it as a full screen.
Of course. Okay. Is it okay?
Perfect, you can continue it.
Hello, everybody. My name is Aida Azizi. I am a PhD student of Tehran University of Medical Sciences in Iran. And the research that I want to represent for you is titled Optimization of Photocatalyst Degradation of Methyl orange using immobilized scoria and ITiO2 nanoparticles in aquatic solution. Introduction. The reason that we thought of improving a photocatalyst was the emerging contaminants. The emerging contaminants include organic, inorganic, and and polymeric compounds that they are very increasing in recent years. For example, annual production of 700,000 tons of dyes is reported in 2015. The characterization of these contaminants is that they are synthetic, they have synthetic nature and complicated structures. One of these contaminants is methyl orange, which is a solid and have a high solubility in water. The reason that we chose methyl orange for this research was the large application in textiles, in paper and leather industries, and they are used in pH indicator. The health problems of this contaminant is its toxicity. It can cause cancer, genetic mutation, and finally, methyl orange is stable in the presence of visible and ultraviolet light, so it can't be degraded in the nature. We have to remove it with a proper treatment. Advanced oxidation process is one of the popular treatment that can be used for the complex chemicals because they produce significant free radicals and can degrade the organic material like methyl orange. There are a lot of methods in advanced oxidation, but we chose to use photocatalysts. The advantages of the photocatalyst is the mineralization of the organic molecules, the lack of need for expensive oxidants, environmental compatibility, a strong oxidation capability, but on the other hand, they have some disadvantages, including the electron-hole recombination, activity in UV wavelengths, the agglomeration. We tried to reduce these disadvantages by improving and modifying the chosen catalyst. We chose one of the widely used catalysts, which it was TiO2. It have a high activity. It is not non-toxic, chemical stability. It has a low cost and have a proper electrical and optical properties. But it has the disadvantages that I mentioned in previous slide. We modified the TiO2 by doping catalysts on it, and we use nickel to shift the activated range wavelengths from ultraviolet to visible light. The ultraviolet light is expensive light source, so we shift the TiO2 activation to the visible light so we can use the visible light, which is free. We can use sunlight as a visible light, which is a free source. Why we use nickel? The photocatalyst activity of nickel was investigated on other catalysts, and it's resulted in promotion of photocatalytic activity of the other catalysts. The researchers mentioned the reasons for this promotion, which it was preventing effect on the recombination of electron hole, which it was the first disadvantage I mentioned, and increasing the specific surface. So by doping nickel on the TiO2, we could remove two of the disadvantage, which it was the electron hole recombination and the UV light activation. The last disadvantage was agglomeration. When we reduce the size of the photocatalyst, the level of the energy will increase. We use the nanocatalyst in this research, so the agglomeration can be happen in the research. The solution for the preventing the agglomeration is using the supportive catalyst on the other materials which have a high surface area and active sites. Among the material for the supports, we use scoria. Why scoria? Scoria is inexpensive and has a high surface area. It has appropriate mechanical strength and full value more than 85%. Also, scoria has been used before in other metal catalysts as a supporting material and used in biological treatment processes. So the aim of this study was determining the efficiency of photocatalyst degradation of methyl orange in water using immobilized scoria and TiO2 nanoparticles using ultraviolet and visible light. And we have some objectives, including the investigation of the effect of pH, irradiation time, methyl orange concentration, and nanoparticle concentration on methyl orange removal efficiency. Material and methods. First of all, I want to mention the procedure that we use to preparation the TiO2. We made the solution 1, including the titanium isopropoxide and 2-propanol, and reduced the pH less than 2 by acetic acid. And the solution 2 was made of distilled water and 2-propanol with equal volume. And then we mixed these two solutions and let it stir for 2 hours. After 24 hours, we raise the pH to 8 by ammonia, and then let it to settle and drain the supernatant. And the remained material was put in the oven to evaporation. And the solid that was resulted after this stage was grinded and calcinated in 450 degrees centigrade. To make the doping the nickel and the TiO2, the only difference between the procedure was adding the nickel in distilled water in solution 2. And for making it to immobilize the NiTiO2 on the scoria, when we mix the two first solution, then we add the scoria, which it was washed with HCl. This is some picture from the procedure. You can see these pictures and the final products that we made. We designed a simple reactor to do our experiments. It was including a magnetic stirrer and a glass plate. We poured the solution contained methyl orange, which was used as our contaminants, and add the catalyst and stir it under a certain time under a UV or visible light. We use the sunlight for UV index in the specific UV index range every day, and we use the 6-watt UV lamp as a ultraviolet light source. We designed the experiments by the design expert software, and we used the central composite design method. The variables that we chose was irradiation time, methyl orange concentration, nanoparticle concentration, and pH. The software gave us 30 runs for each light source. So we performed 60 runs for both UV and visible light. Results and discussion. First of all, we have to prove that doping and immobilizing was happened and it was successful. We used the XRD pattern to improve that the crystallization was happened, and the nickel that you can see that the nickel has been doped successfully on RTiO2. And then we use SEM to show that our particle was in non-scale size, and IDAX analysis, which you can see that titanium element was increased and nickel was added to the elements of the scoria. So the immobilization was happened successfully. We use DR spectra for showing the shifting adsorption edge. The adsorption edge that you can see here was increased from 400 to more than 500. So the catalyst could active on the under the visible light, which it was more than 500 nanometers. We use the RSM model to show the results. You can see these plots. It is contain 4 color, including blue, green, yellow, and red. The blue and green show the lower efficiency, and yellow and red color show the higher efficiencies. The efficiency that we mentioned means the removal of the methyl orange with the catalyst that we made. The variables that we chose from for the design or experiments, we are investigate the results. You can see the irradiation time in the UV light, which it is in the left side of the plot. By increasing the irradiation time, the efficiency is increased. And in the right side, you can see the visible light efficiency, which it is the same with ultraviolet. And by increasing the irradiation time, you can see the increasing of the efficiency. But in total, you can see that the efficiency of visible light is much more than the UV light. Increase the reaction time from 36 minutes to 53 minutes, and we saw the increasing the methyl orange removal in both light source. And the other parameter is pH. By increasing the pH, just like the previous one, we can see the increasing the efficiency in both UV and visible light, and the visible light has the more efficiency, just like the other one. By increasing the amount of catalyst, you can see that it is so much effective, and you can see this that the efficiency significantly increased by increasing the catalyst amount. And just like the other ones, the visible light has the more efficiency. But about the methyl orange concentration, which is our contaminants, by increasing the methyl orange concentration, the photocatalyst degradation was decreased and our efficiency was decreased. It is expected that by increasing the concentration of contaminant, we can have the less efficiency. If we can optimize the variable, including the parameters that we talked about, by choosing the optimized amount, we can have near 99% efficiency in visible light and 94% in UV light. Our model was here you can see that our model was verified by the software, and the proposed model for visible and ultraviolet can be correct with accuracy of 93 and 94 respectively. Excuse me. We have to in the photocatalyst degradation research, we have to determine the electrical energy consumption. We use EEO as our index of the energy consumption. It is defined as the number of kilowatt hours of electrical energy required to reduce the concentration of a pollutant by 1 order of magnitude unit volume of contaminated water. It is the formula that we chose, and you can see that we have to use the input power to calculate this this energy consumption. But we just use power in UV light experiment, so the sunlight was completely free. The results show that 10% of nickel doping on the TiO2 has the less energy consumption that the other kinds of catalysts that we made, and we used this catalyst for our UV light experiments. The sunlight was free. Conclusion: the XRD pattern, DRS, SEM, and EDAX test verified the modification of our nanocatalyst. The SEM photo and EDAX confirmed the successfully doping of successfully coating and immobilizing the catalyst on the scoria. The XRD patterns showed the successful doping, and DRS showed the transferring the activation range from UV light to visible light, and the efficiency value reached 90% in UV light and 98% in visible light in 45 minutes, which it was so much less than other researchers that we reviewed. The efficiency increased with increasing pH, irradiation time, and catalyst concentration, but with increasing the methyl orange concentration, the efficiency decreased. The removal efficiency in all the experiments in visible light was better than the ultraviolet light. We have some suggestion for future studies. We couldn't analyze the XPS, which can investigate the placement of electron in the orbital. We didn't have the source and time for do this analysis. And the investigation of the presence of organic matter by using this chemical oxygen demand as an index can be investigate in the future studies, and using this catalyst on the other resident material can be good in future. Thank you for your attention.
Thank you, Dr. Nahid. Aziz, is anyone having any questions?
Thanks very much, Nahid Aziz, for the valuable presentation.
You're welcome. I hope it was good for you and the others.
I think there are no questions. Let's move to our next presentation by Dr. Osman Adyozal from Firat University, Turkey. Doctor, are you ready with your presentation?
Yeah, I am ready.
Okay, now I'm making you as a presenter now. Please share your screen.
Yeah.
Doctor, please click on the PPT button. I think doctor will join within few minutes. Let's wait for him. Dr. Osman, please share your screen. We can see your screen. Please click on that PPT. Yes. No. Please make it as a full screen. You need to click on that slideshow button. Bottom of your PPT, you'll be having slideshow button. Dr. Osman, can you unmute yourself so that we can hear your presentation? Dr. Osman, can you hear me? Dr. Osman, we have made you as a presenter now. Please share your screen.
There are two sharing sections. Should I share on the screen?
I think you're having only one login. Yes, you can share your PPT from there also. Are you able to share your screen now?
Yeah, I can see, but I cannot manage after clicking the share button.
Yes, we can see your screen. Please click on that PPT button. You need to click on that PPT icon.
Yeah.
Dr. Osman, I think you have unclicked the screen button.
Yeah, okay. And
Dr. Osman, please share your screen.
there is two screen on the main menu. There are screen menu, and in the center of the screen there is another share button. Shall
Doctor,
I click the share button?
yeah, yes, you can. You need to click on that screen share button. Yes, we can see your screen now. Please click on the PPT.
Is it okay now?
Yes, please
Yeah,
continue with
okay.
your talk.
Yeah, okay. Thank you very
Thank
much. Good morning, good afternoon, and good evening to all at the conference. I am very happy to join this important conference and deliver my talk. Let me introduce that this is a multidisciplinary conference, and I am sure every scientist is not familiar with every subject of the science. Therefore, at the beginning of my presentation, I will introduce the basic terms and definition related to the shape memory effect, and introduce the experimental studies performed on the copper-based shape memory alloys. Shape memory alloys are thermoresponsive material and exhibit a peculiar property called shape memory effect. This effect is initiated by thermomechanical treatments, cooling and heating processes, and perform thermal on heating and cooling. And this behavior can be called thermal memory or thermoelasticity. These alloys can be plastically deformed in low temperature conditions and record the original shape just by thermal means on heating or the reverse oscillating transformation temperature after removing the strain. These materials cycle between deformed and original shapes on cooling and heating. These alloys exhibit another property called superelasticity, which is performed by mechanical stresses in a constant temperature, and this behavior can be called mechanical memory too. This is basic illustration of shape memory effect. First step is cooling in the shape memory effect, and on cooling, the shape of material doesn't change, but crystallographic transformations occur in the atomic level. Second step is the deformation. This is plastic deformation, and the material keeps the deformed shape after releasing due to the plastic deformation, and strain energy is stored in the material and released on heating by recovering the original shape, and the shape of material cycle between original and deformed shape on heating and cooling. Shape memory effect and superelasticity is result of thermoresponsive and thermomechanical reaction and stress-induced magnetic transformation and evaluated by the structural change in atomic scale. Shape memory effect is performed in a temperature interval depending on forward and reverse transformation on cooling and heating respectively. Superelasticity is performed in the parent Austin phase region just above the Austin phase temperature. For the superelasticity, materials are stressed in the parent phase region, and shape recovery is performed instantly and simultaneously upon releasing the applied stress. This is stress strain hysteresis. This is temperature hysteresis of shape memory effect. Thermal induced martensitic transformation occurs on cooling and start at MS temperatures and completed at MF temperatures. Also, below the MF temperature, the materials are completely at the product state at the room temperatures. Whereas austenitic transformation occurred on heating and start AS temperatures and completed at AF temperature. This is stress strain characteristic in shape memory effect and superelasticity. In the shape memory effect, the material is deformed in the low temperature condition. As you can see, early stage of the deformations exhibit elastic material behavior. And stress-induced martensitic transformations occurs at the plateau level. As you can see, in the superelasticity, stressing and releasing paths are different, and hysteresis lobes refers to the energy dissipation. This is another illustration of shape memory effect and superelasticity. In the shape memory effect, the material is deformed in the low temperature condition. This is plastic deformation, and material keeps the deformed shape on releasing. And on heating, deformed shape turn into the ordered original parent phase structures, and shape of material cycle between original parent phase shape and deformed shape on heating and cooling. In the superelasticity, the material is stressing at the parent phase region and performed simultaneously after releasing by exhibiting elastic material behavior. This is schematic illustration of shape memory cycle in the crystallographic level. In the shape memory effect, the ordered parent phase structures turn into the determinate martensitic structures on cooling. Let me inform you that shape memory effect and superelasticity is performed at the beta phase region of the material, and ordered structure is essential. On cooling, ordered parent phase structures turn into the twin martensitic structures by means of thermally induced martensitic transformation. And by the deformation, twin martensitic structures turn into the determinate martensitic structures by means of stress-induced martensitic transformation. And on heating, after these processes, determinate martensitic structures turn into the ordered parent phase structures on heating, and crystal structure of material cycle between ordered parent phase structures and determinate martensitic structures on heating and cooling. This is also schematic of superelasticity. In the superelasticity, the material is stressed in the parent phase region, and ordered parent phase structures turn into the determinate martensitic structures by means of stress-induced martensitic transformation. On releasing, determinate martensitic structures turn into the ordered parent phase structures, and crystal structure of material cycle between determinate martensitic structures and ordered parent phase structures on stressing and releasing. Superelasticity is also linked to stress-induced martensitic transformation, which is induced by applying only mechanical stress. With this stress, parent austenite phase structures turn into the determinate martensitic structures as in the deformation step, and different determinate martensitic structures turn into the parent phase structure upon releasing. It is important that stress strain curve exhibit nonlinear behavior when stressing and releasing paths are different, and hysteresis lobes refers to the energy dissipation. This is stressing and releasing part in the superelasticity. By the stressing, ordered parenthesis structures turn into the Yathivan martensitic structures by means of stress-induced martensitic transformation. As you can see, stressing and releasing paths are different, and hysteresis lobes refers to the energy dissipation. Martensitic transformations are first-order solid-state phase transition and occurs in a few steps with the cooperative movement of atom in displacive manner. Therefore, does transition have diffusionist character and product martensitic phase inherits the order of parent austenitic phase. Martensitic transformations mainly occur into basic step in the beta phase region of material. One is Bain distortion, and second one is lattice invariant chair. As I mentioned, shape-memory effect and superelasticity is observed in the beta phase region of material, and ordered phase is essential. These are the basic beta phase structures. This is this is ordinary BCC cubic structure. This is cesium chloride type ordered phase structure. This is DO3 type crystal structure. This is also L21 type crystal structures. Bain distortion is mainly affected in ternary copper shape alloys and consists of an expansion of 26% in 110 type axis, 100 type axis called Bain axis, and a compression of 11% in on the 110 type direction perpendicular to the Bain axis. There are three Bain axes, 100, 010, and 001, and BCC-based unit cell turn into the body-centric cubic structures as three variants in different orientations. Lattice invariant shares occurs martensitic variance on one monotype planes of austenitic matrix, which is basal plane of martensite. Their shares occurs into opposite direction, one monotype direction on the one monotype planes. One mono planes family represents 6 certain planes, and totally 24 martensitic variants occurs. These planes are listed as follows: 110, minus 1, minus 110, 101, minus 101, 011, 01, minus 1. Lattice invariant share and lattice twinning is not uniform in coupled shape alloys, and that share causes the formation of structures on the one monotype planes of parent phase. And the basal plane turn into the unusual layer structure, which consists of an array of closed bucket plane, which complicated stacking sequences called as 3R, 9R, or 18R martensite, depending on the stacking sequences. The periodicity, and therefore the unit cell, is completed through 18 layers in directions Z in case of 18R martensitic structures. This is the formation of layer structures in the shape-memory effect. This is taking of one monotype planes of austenitic matrix with the lattice invariant share. The stackings turn into the stackings ABC, BCA, CAB, and A4 18R martensitic structures. This is another illustration of the formation of layer structures in DO3 type parenthesis structure for 18R martensitic structures. These are the basic terms and definitions related to the shape-memory effect and superelasticity. Experimental studies were performed to copper shape-memory alloys. These are copper zinc aluminium and copper aluminium mangan alloys. and you can see the alloy compositions, and these compositions were selected in the beta phase region of the material. As you can see, martensit start and martensit finish temperatures are over the room temperature for both of the alloy samples, and both of the alloy samples are completely martensitic state at the room temperature. Specimens obtained from these alloys were solution treated and homogenated in the beta phase field as following, then quenched in ice brine and aged at the room temperatures. These homogenation temperatures are 830 and 700 degrees for copper, zinc, aluminum, and copper, aluminum, mangan alloy samples. And these temperatures were selected in the beta phase region of the material. Powder specimens for X-ray examination were prepared by filling the alloys, and the powder specimens were sealed in evacuated cross tube and giving beta phase homogenation treatment. These are the same temperature, 830 and 700 degrees for copper, zinc, aluminum, and copper, aluminum, mangan alloy samples. And powder diffractorams were obtained for all the specimens at the different stage of aging at the room temperature in a long time interval. This is an X-ray diffractoram taken from copper, zinc, aluminum alloy sample after long-term aging at room temperature, about 15 years after quenching. As you can see, peak intensities are different, and this diffractoram exhibits superlattice reflection. As you can see on the diffractoram, these peak waves are important. These are 1 to 2, 202, 1 to 8, 208, 1 to 10, 2010, 1 to 10, 2010, and others. This is another X-ray diffractoram taken, second alloy samples after long-term aging at room temperature, about 15 years after the quenching. As you can see, this diffractoram also exhibits the same characters with these plane pairs. A series of X-ray diffractoram have been taken from both of the alloy samples in a long time interval, and some changes have been observed in the diffraction angles, peak intensities, and peak characteristics with age and duration. In particular, some of the successive peak pairs shift each other, and these successive pairs provide the following relation for ATNR martensitic structures. I mentioned these plane pairs on the diffractoram, and these are 1 to 2, 202, 1 to 8, 208, 1 to 10, 2010, 040, 320, and others. At the long-term investigation, it is observed that these peak pairs come close to each other with age and duration, and this change refers to the changes in the crystal structure of material. Also, this change refers to the rearrangement of atoms in the dispersal manner. Second experimental study were performed on electron microscopy by taking electron diffraction patterns. As you can see, electron diffraction patterns also exhibit superlattice reflection. Shape-momer effect is evaluated by the crystal structural change in the microscale by means of martensitic transformation. The fundamental structures of beta-type martensites are orthorhombic closed packet structures, which consist of an array of closed packet planes in the shape of Bakker-based shape-momer alloys. The beta-type martensite has the layered structures and are characterized by the stacking sequences depending on in the parent phase. Couple-way ternary always have divotritype superlatives in parent Arsenis phase region, and the following sequences occur with martensite formation. The sequences are A, B, C, C, B, C, A, C, A, B, A, B, C, B, C, and A, AC for 18 are martensitic structures. On the basis of Arsenis martensitylation, the basal plane of 9R or 18R martensite originated from the 1-1 type planes of parent austenitic space on which lattice invariant shells occurred into opposite direction during the martensitic transformation. These are the references. And thank you very much for your attention. If anybody has questions, I'll try to answer. Questions, comments?
Thank you, Dr. Osman. Is anyone having any questions?
I think there is no questions, no comment. Thanks again to all to listen my talk.
I think there are no questions. Thank you once again for your presence and presentation, Dr. Osman.
Thank you too.
Thank you. Let's have a lunch break for half an hour and stay connected.
Hi, everyone.
I hope everyone are back from the lunch break. Let's start our afternoon session. Our first talk will be Dr. Syed
Sylvain or Sylvain.
Yeah. Our first
Sylvain.
talk will be by Dr. Sylvian Sif from Indicoa Group, Lebanon. Doctor, are you ready with your presentation?
Yes, I'm ready.
Okay, now I'm making you as a presenter now. Please share your screen.
Okay. So, can everyone see my screen? I'm putting the
No,
camera on. Well, all right.
you need to unclick the camera button, sorry, screen button, so that we can able to see your screen.
Okay.
You need to
Is
click
this
on that screen button.
the green button? Oh, I see. Okay.
Screen button.
Yes, yes, I did that. Now, can you see it?
Mm-hmm. No,
Okay. No.
no.
Let me try again. Okay. Share, and then the green button. Okay. Still no.
No, doctor, we can't able to see your screen.
Switch. Okay. All right. I clicked on the screen. When you click the
You need to
screen.
click on that screen button. Yes, now we can see your presentation.
Oh, okay. Great. Great.
Please make it as a full screen.
Yeah, maybe because I put the full screen. Okay. I will put that one.
Please click on that slideshow button so that we can see it full screen.
Okay. There's just some things in the way. One second.
Mm-hmm.
I'm trying to minimize this one here. Okay, I can't. One now. Okay. Okay. That's bad. All right. So welcome everyone to my presentation. Today I'm going to be talking about how we can recycle food packaging waste. Okay, here we're talking about film, flexible film waste, as carrier resins for short glass fiber composites. Okay, and before to proceed with the technical part, I'd like to talk a bit about what my company does. So Indefco is a multinational packaging firm, and it has over 10,000 employees worldwide, all over the Middle East. We have plants in North America, Africa as well, and distribution centers in Europe. So we have over 40 manufacturing plants, and we're over 40 commercial companies. The division I work at in the R&D department is an Indefco Flexible Packaging division, where we produce a lot of the polyethylene,
Sorry for the
polypropylene.
interruption, doctor.
Yes, sure. Yes,
I
go
think
ahead.
few of the speakers didn't see anything of your presentation.
You can't see the presentation?
Yeah, few of the speakers didn't saw.
Okay. Let me try.
Just unclick that screen button and again present your talk.
Okay. Now, can you see?
No.
Okay. I'm sharing. It's showing that I'm sharing the screen.
No, for the few of them, they didn't get any access for your screen.
Oh, let me try again. Let me stop sharing the screen and trying again.
Yes, please.
Okay. How about now?
Yeah, now it's perfect. You can continue with your talk.
Okay, great. So the division that we're focusing on for this presentation is in the flexible packaging division of waste like polyethylene, polypropylene, as well as polyamide. We have PET bottles, thermoforming operations for polypropylene and polystyrene trays. So how we can recycle some of these products efficiently to make useful end products for sectors, for instance, in injection molding applications. Okay, other divisions in the group include the paper division and the consumer goods division that produces feminine napkins, wipes, baby diapers, aluminum foil, and tissue paper, for instance. So we serve a lot of sectors, including agricultural, where we make greenhouse films, mulch films, greenhouse covers, and so on. We serve the food sector, and here my presentation is on food packaging, so how to recycle the food packaging waste from this sector efficiently. We have household care packaging, dairy and ice cream, personal care packaging, so many different sectors that we serve. So what is the motivation of this research? The motivation is that we know that plastics really pollute our landscapes, our beaches, and our oceans. And we know that most of the plastics that we work with are fossil-based, and they are at the same time non-biodegradable, whereby some of the plastic bags could take up to 1,000 years to totally decompose. So this creates a lot of waste stream that we need to take care of. Okay? And we need to basically stop littering because littering kills animals, and we need to focus more on mechanical recycling of this waste to keep it in the solid state and keeping it in the useful form without having it to produce CO2 emissions over the hundreds and thousands of years, and at the same time not littering our landscapes and our beaches. So when we look at the waste hierarchy, we know that waste management has many different levels of priority. The best preferable methods, the most preferable methods are prevention, of course, and reducing the amount or your dependence on the plastic waste or the plastic products. Right. So here we need to look at also the recycling. Recycling is somewhere in the middle of the structural hierarchy. And disposal is the least preferable method. As you saw earlier, disposal causes the plastic to go into our waste streams, into our rivers, and eventually into the oceans, killing our animals, marine life, and hurting our ecosystems. So when we talk about mechanical recycling process, the mechanical recycling process consists of two major parts. The first part is the preconditioning unit, where the material undergoes a shredding process. So we cut it into what we call flakes. And this causes a higher overall surface area so that you can clean in your washing step, you can clean the plastic products more efficiently. Rather than having thick parts, you're basically cutting them to many pieces so you can clean them inside and out in a better fashion. We have a metal separator to remove, this is by magnetic field, we can remove metals from our plastic. Then we have the granulation section where we get smaller flakes. Then we can do our frictional washing, and here by washing, we're talking about basically either hot washing or cold washing, and washing with solvents. So sometimes we need to remove ink, for instance, with ethanol, or glue with a certain solvent. And like for glue, between multi-layer packaging waste, so when you have different layers, you remove the glue by like ethyl acetate or other solvents like that. We also have our separation unit that precedes right before the washing step. We have the plastic separation, where, for instance, with the floating sink tank, we can separate plastics based on the density difference. So, for instance, polyethylene and polypropylene have densities lower than 1 gram per centimeter cube, so they can float onto the surface of the water, whereas PET or polystyrene have densities higher than 1 gram per centimeter cube, and then they sink into the bottom of the water tank. And that way you can separate them more efficiently. And then you have finally our mechanical and our thermal drying, especially for hygroscopic or hydrophilic material, where we need to remove the water that can cause degradation if when we go to the next step, which is the extrusion step. So this is called hydrolytic degradation or degradation under high heat. Okay, so we need to remove the water to prevent that. So the next step is the extrusion step. And here the material goes through a plasticizing and homogenizing section in a single screw extruder. And then it gets fed in the molten state using a gear pump, okay, a gear melt pump into a twin screw extruder. And the benefits of the twin screw extruder is that you can add fillers and reinforcing agents to compensate for some of the losses that are brought about by the degradation of the plastic under high heat and high shearing, okay, during extrusion. So by adding these fillers and reinforcing agents, and here we can also add antioxidants, and we have a side feeder, for instance, for these fillers to feed them wherever we want on the twin screw line. We can feed these fillers and antioxidants. We can feed them to compensate for these losses of properties and get good stiffness and good strength properties, for instance. We also have a degassing zone where we can remove moisture even further using a vacuum suction device, for instance. And what's nice about this also is that we can add compatibilizers or coupling agents, okay, to compatibilize incompatible polymers, because we know that using the twin screw as a superior mixing device, we can get very high shear and very high good chemical reaction to take place, good reactivity to get good compatibilization between the incompatible polymers, where we can link polar and non-polar polymers together in a better fashion. So when we look at the recycling of incompatible material, we know that for multi-layer waste, multi-layer packaging waste, we cannot have more than 5 to 10% barrier polymers, such as polyamide or EVOH, in our multi-layer packaging before we start to consider them as non-recyclable. Okay, so 5 to 10% is the maximum level. And a lot of times to get good barrier performance to oxygen and to water vapor in the food packaging sector, to keep the food lasting longer, we need more than 10% of these barrier polymers. So with the twin screw extruder, we have the possibility to do that, because we can add, as I said, coupling or compatibilizing agents efficiently, okay, because you have higher total shear heating for diffusion and chemical reactions to take place, so that this chemical bonding can take place between the polar and non-polar material. We also have in the twin screw extruder, as I mentioned, the possibility of adding the reinforcing fillers or additives and a vacuum suction for moisture sensitive materials. For cast or blown film tie layers, we need a lower amount of grafted maleic anhydride. And here with the coupling agent or compatibilizing agents, usually they have a lot of times in the food packaging sector, grafted maleic anhydride as your polar part that links to the polar polymers or your barrier polar polymers. So a lower amount is needed to compatibilize and bond the non-polar and polar phases together as tie layers. But when we want to do a dispersion of a phase inside of another in the twin screw step, we need to add a higher amount to get you, because you have a higher area, higher surface area of the filler phase that you need to couple and to disperse in your twin screw extruder. Okay, so you need more maleic anhydride to compatibilize and disperse the polymer particles into smaller particles, so that you get good dispersion and good distribution and your best combined properties. So the objectives is to add of the research is to add the food packaging waste, which consists mainly, as you will see in a little bit, of polyethylene and polyamide and polypropylene waste, PE, PP, PA waste, and to add short glass fiber reinforcements, okay, and using the twin screw extruder to come up with a composite suitable for injection molding applications, like you can see in this picture here. Here we see that we have testing bars to test the stiffness and the tensile strength and the flexural properties. And we can also make bars for impact strength properties as well for different injection molding applications, such as its gear pump application in here. So what we need to do is to have the good dispersion and good distribution, whereby we don't have agglomerates, but we rather disperse them using the coupling agent and the twin screw process. And after this dispersion, we can get subsequent distribution. And when you have good dispersion and good distribution, you get the best combined properties. And you can see here in this picture, you could have bad dispersion with bad distribution, a bad dispersion with a good distribution, where by distribution we mean spatial uniformity or equal distances between the particles in 3 dimensions. Dispersion means that we pull the particles apart from each other. And then you could also have good dispersion but bad distribution. But what we want to get is a good dispersion, good distribution of the filler and or the polymer particles in the blend to get the best combined properties or the best synergistic improvement of properties, and at the same time, of course, high product consistency. And we referred to this in the subsequent slides as homogeneous dispersion of our filler phase. So when we talk about coupling or compatibilizing agents, the compatibilizer is used when we talk about 2 incompatible polymers like polyethylene and polyamide. And the coupling agent as a term is used when we talk about incompatible polymer with a filler. So we call it now a coupling agent, but it's really the same material, but it depends on your application, what you're trying to link together, what phases you're trying to link together. And we know that what we use it for is to link a hydrophobic polymer or non-polar polymer like polyethylene to a hydrophilic polymer or a hydrophilic filler like polyamide or calcium carbonate, which is a hydrophilic filler. And when we add these polymers and add a compatibilizer for these polymers, we can really reduce our dispersed phase size. So we reduce the size of the polymer B, in this case in green, to a smaller level. So we can get a total area, surface area on the interface between the different phases as being higher. So we will have a higher total surface area when we have smaller particles. So with the higher interfacial area, you get better combined properties. Okay, because you get, for instance, better stress transfer, better really total properties. Okay, so we have a homogeneous dispersion and strong interfacial adhesion using these agents in our twin screw extrusion step. And as I said, when we need to add them in the twin screw extruder. So the ones that are available in the food packaging waste as tie-layer resins in the multi-layer waste are not enough. We need to add more in the twin screw step because of this higher total surface area that needs to be compatibilized. So for the material used in the research, we have PE, PP, PA waste, polyethylene, polypropylene, polyamide food packaging, multi-layer cast film waste. That is post-industrial waste. It's not post-consumer, but rather post-industrial from our companies at Endefco. So we take the waste from the extrusion of the cast films and we recycle it using a twin screw recycling process. And we can call it now PEPA waste because it's PE, PP, PA. We call it PEPA waste. And the chemical composition is around 30-70 polyamide 6 to polypropylene blend. Okay, with a small amount of polyethylene and around 6% PP grafted with maleic anhydride tie-layer resin. So the flakes are first dried in an oven at 60 degrees Celsius overnight prior to the extrusion process to remove all the moisture that can cause gels or fish eyes in our final product when they evaporate. When the moisture evaporates, it can cause these fish eyes or weak points in our products. So we remove it by drying step. And to further reduce the moisture content, we use the vacuum system in the twin screw extruder to remove the moisture. So to talk about the raw material a little bit, polyethylene consists of the simple monomer, ethylene monomer, which is a C2H4 repeating unit, to produce, when you add it n number of times in your polymerization reactor, we produce our polyethylene polymer. And the n, or number of times that we repeat this monomer, could vary between 1800 to around 17,000 and even more. And this affects your mechanical properties. Of course, the higher your n, the higher is your molecular weight, which means the more entanglements between your polymer chains. More entanglements mean better mechanical properties like better stiffness, better tensile strength, better impact strength, and so on. And for polyethylene, we have different structures, including HDPE, high density polyethylene, whereby in a given volume, as in this imaginary square here, which is actually, it could be thought of as a cube, but this is in 2 dimensions. So your high density polyethylene has a density of 0.94 to 0.97 gram per centimeter cubed, because the chains are tightly packed together, because we don't have a high amount of these comonomer branches, which are your basically linear alpha olefin branches. So when we don't have a high amount of these, the chains can stack very tightly together, giving you high density. Then we have the LLDPE, linear low density polyethylene, where we have more of these comonomer branches, yielding a lower density. Now we reach densities of 0.915 to 0.94 gram per centimeter cubed. And we have LDPE, where we have extensive long chain branching, okay, where the branches are very long that they can entangle with one another, okay, where the density is also close to LLDPE, because you have a lot of branches that are close to one another. Even though the voids are higher between the chain backbones, because of the extensive branching, you still get densities close to those of LLDPE. So polyethylene is lightweight, durable, with variable crystalline structure. It is of low strength, hardness, and rigidity, but has high ductility and impact strength, as well as low friction as the properties. It also has high creep, or elongation over time under constant stress, and it can be reduced by the addition of the short fibers. And the branching structure can affect the density. As I said, more branches mean a lower density, okay, or more extensive, not only more branches, longer branches could also mean a lower density, not just the amount of branching, but the length of branching both affect. So here you can affect properties like stiffness to toughness balance, the tensile strength, tear strength, and ductility. And polyethylene is used in a wide variety of products, including greenhouse film, stretch hood, heavy-duty shipping sacks, collation shrink, grocery bags, and garbage bins, and so on. For instance, the high-density polyethylene is used a lot in the garbage bins, bottle caps, of your more rigid kind of structures. For polypropylene, okay, it has the monomer CH2CHCA3, and it has basically higher stiffness than polyethylene. Barrier. Polyethylene also has a very good moisture barrier because it is hydrophobic. It does not absorb water, just like the polypropylene. And polypropylene is in fact used in pipes and also a lot in car bumpers and different devices in the automobiles, also in raffia bags. So many different products are used with polypropylene. And polyamide has this kind of repeating structure, the C6H11NO. It is high clarity, very stiff. It's really an engineering polymer with very high stiffness and strength. It has high temperature resistance due to the hydrogen bonding. Okay, it can have a very high gas transition, very high melting point compared to polyethylene and polypropylene. It has good thermoformability and very good barrier to oxygen gas and to other gases. And it has very good puncture resistance as well. And you can see here some of the different products like the plastic gears, food barrier packaging. because of the oxygen barrier. Automobile under the hood applications and the fishing lines all use nylon polymers. Now for the PP grafted maleic anhydride coupling or compatibilizing agent, we added it in this research to the existing tie layers in the flakes during twin screw compounding to enhance the glass fiber and polyamide 6 dispersion, and because these are polar materials, and subsequent distribution inside the non-polar polyethylene and polypropylene resins, and to enhance the interfacial adhesion between the polar and the non-polar parts. This will result in a higher overall matrix to fiber interfacial adhesion strength, giving us better properties in this case. So the esterification between the hydroxyl groups on the surface of the polar organosilane treated short glass fiber, so short glass fiber meaning SGF, and the acid anhydride groups of the PP grafted maleic anhydride can actually form a covalent bond in the twin screw extrusion, high diffusion, high shearing process. So good dispersion and subsequent distribution of the epoxy silane treated polar short glass fiber in the polyamide 6 part of the PEPA waste, and hence the good interfacial adhesion between the short glass fiber and the polyamide 6 is due to the short glass fiber polyamide 6 coupling reactions. Okay, so here we're talking about the polar glass fiber, what kind of treatment it has. So it's an epoxy silane treatment, and it can basically, this treatment allows it to get dispersed and to adhere very well to the polyamide 6 phase in our PEPA waste. And the short glass fiber polyamide 6 coupling reaction is in between the epoxy pendant group on the surface of the polar organosilane treated fiberglass and the carbonyl group of the polyamide 6 part of the PEPA waste. So the blends that were produced involve PEPA with 0% short glass fiber. You can see that here, just adding only antioxidants, phosphatic and phenolic antioxidants for protection during processing and long-term protection. We also have then 7% with and without the PP grafted maleic anhydride coupling agent. Okay, and here we added 3% PP grafted maleic anhydride versus 0 or without the PP grafted maleic anhydride. And then we varied the amount of the short glass fiber up to 40% short glass fiber total. And we then increased the PP grafted maleic anhydride level proportionally with the increase in the short glass fiber content. So as we increase the short glass fiber, we had to increase the PP grafted maleic anhydride level to get the good dispersion and distribution inside the PEPA waste. So the short glass fiber used have initial length of 4 millimeter and a nominal diameter of 10 micrometer with a density of around 2.6 gram per centimeter cubed. Okay, it's of a type ECR, which is boron free. So ECR is a good one to work with, very environmentally friendly. The glass fibers are treated with epoxy silane to reinforce a broad range of polyamide resins. And then these composite pellets, after the twin screw extrusion, were injection molded to produce composite materials for different commercial and engineering applications. So in the twin screw extrusion step, the dried PEPA flakes and the glass fiber were compounded in an intermeshing co-rotating twin screw extruder, having an L/D ratio of 48 and a screw diameter of 22 millimeter, and temperature profile ranged between 200 to 220 degrees Celsius at the die. The extrudates were then obtained, quenched in cold water, and then pelletized. Okay, and what we did here, and the nice thing that is really novel about this, is that we fed the glass fiber using a side feeder, and we concentrated the kneading blocks, which give the very high shearing elements. We concentrated them at the beginning part to melt the polymer well and to prevent breakage of the glass fiber. So we didn't put any, or we put minimal kneading blocks after the side feeder where we fed in our glass fiber. Because the whole point is to protect as much as possible the glass fibers against breakage, because we need to preserve the glass fiber length, keeping the length of the fibers above a critical length for fiber reinforcement or for effective reinforcement. So the fibers were fed into the lower viscosity molten polymer state in the side feeder at a later stage during the twin screw extrusion step, okay, rather than the high viscosity, high shearing solid state. So kneading blocks were also separated as much as possible to decrease their demolishing effect on the fiberglass, and left-handed elements were placed between conveying parts to prevent backwards flow into the kneading blocks. So we never put a kneading block followed directly by a left-handed element, because the left-handed element causes the reverse flowing, and this reverse flowing will cause the flow to go to the kneading blocks and for the glass fibers to really lose their length, to get broken again and again many times. Now for injection molding, we molded different bars, ASTM bars, for tensile, flexural, and impact properties. Okay, and we injection molded the specimens using a 150-ton clamping force machine, using 220 degrees Celsius temperature, a screw speed of around 300 RPM, a holding time in the mold of 30 seconds, a 23 Celsius mold temperature, and a mold cooling time of around 30 seconds. So what we need to do is basically, when we do our composites, we need to think of the load transfer mechanism in glass fiber composites. And the load transfer mechanism occurs because of the result of the difference of the strain in the fibers and the strain in the matrix. Shear stresses are induced around the fibers in the direction of the fiber axes because of the difference in these strains. These shear forces acting near both ends of a fiber stress the fiber in tension, causing orientation of both the matrix and the fibers in the flow direction, and hence you get the transfer of stress and higher stiffness and higher strength properties between the fibers and the matrix, the polymer matrix. So when we talk about critical length, we can measure the critical length of the fibers after injection molding, okay, by burning off the matrix at 600 degrees Celsius in the furnace, high temperature furnace. And after we burn off the polymer matrix, by using an optical microscope, we can measure the length and take an average measurement of the length of these fibers, where we take approximately the length of 50 fibers. Okay, using ImageJ software, we can basically measure these lengths. And the critical length for effective polymer reinforcement is determined using the ratio L over D is equal to sigma F, which is the tensile strength of the fiber, divided by 2 times the shear strength of the fiber matrix interface. Length, this is the critical length, D is the diameter of the fibers. For polymer blends, this value is average based on the loading level of each polymer component. So basically, the value of the tau, the shear strength, could be averaged based on the different polymer components like PE, PP, and PA components. And when we find this average shear strength, okay, we found that the critical length in our case for the fiber reinforcement was found to be 157 micrometer. So we need to keep or preserve the fibers to be at this length or above this length to get good stiffness and good strength properties. Okay, so here, why is this important also is because when we have fibers below this critical length, okay, then we can have fiber pull out, whereby actually the fibers can pull out of a void, okay, during, if you have weak interfacial adhesion, you can have the fibers that are below the LC or below critical length pulling out of the matrix, of the polymer matrix. So fiber ends are the points of stress concentration, which weaken the composite and cause premature failure. So when the average critical length is below the critical length and the criteria for shock absorption are met, when the fibers debond and pull out of the matrix, and these criteria include that the glass fiber diameter has to be less than 10 micrometer to obtain small microvoids. the glass fiber aspect ratio, or length to diameter ratio of the cylindrical glass fibers has to be close to unity or close to 1 to avoid high stress concentration. Okay, fiber debonding has to occur prior to the yield strain of the polymer matrix. So we also have to have this debonding occurring earlier. In these cases, 1, 2, 3, the fibers can actually improve the impact strength of the polymer in these cases. Okay, so it depends on the dimensions of the fiber and the length, of course, the length and the interfacial adhesion between the fiber and the matrix. Okay. So when we calculated the weight average and number average length of our glass fibers and our pore dispersity, which is LW over LN, the weight average over number average lengths, taking the fractions of each length population into account, we found that in many cases, the LN values lies between 108 to 199 micrometer, whereas the LW lies between 62 and 242 micrometer, and the pore dispersity between 1.16 and 1.5. This means that we are similar to or higher than the critical glass fiber length required for effective mechanical reinforcement, which means that we expect more stiffness and more strength properties rather than better improvement in the impact strength properties. So we expect more of the reinforcement properties. So by scanning electron microscopy, we found that we had basically misaligned fibers. Okay, when we look at the SCM figures of the fracture surfaces, we found misaligned fibers and a larger number of fibers in the fractured surfaces, which tells us that the fracture was mainly of the glass fiber rather than the polymer matrix. And this makes sense because the glass fibers are much more brittle than the polymer matrix. So fiber breakage is dominant over the fiber pull-out. Okay, and the glass fibers are well bonded to the surrounding PEPA matrix. We found good interfacial adhesion in our SCM photographs. And here you can see in C, we also took the SCM of an unbroken sample of PEPA with 40% glass fiber composite. Okay, so for the 20% loaded composite, we found an appropriate degree of dispersion and distribution of the glass fibers in the PEPA matrix, and hence a high overall interfacial adhesion between the glass fiber and the PEPA matrix. Whereas for the 40% loaded composite, we found some agglomeration, as you can see here in B and C, and this means a lower overall matrix fiber interfacial adhesion due to insufficient polyamide 6 and PP grafted maleic anhydride matrix materials. So really an insufficient polar phase for the glass fibers to disperse in, because the glass fibers are also polar at the same time. Now, when we did DSC, we did it to calculate the percent crystallinity using the standard formula known in the literature, where we take the enthalpy of melting, delta HM, divided by the maximum delta HM times 1 minus F, F being the weight fraction of the glass fibers. So delta HM0 is the reference value of the heat of melting. If the polymers were considered to be 100% crystalline, the delta HM here is the actual area over the melting peak in our DSC study. Okay, and then we had to normalize it or to take into account the fiber percentage so that we can actually calculate the percentage crystallinity of our crystallizable polymer material. Okay, and the reference value for melting of pure polymers was 207 joule per gram for pure PP and 230 joule per gram for pure polyamide 6. And with these, you can take from the 30-70 ratio, you can basically calculate by multiplying 30% times 207 plus 70% times the 230, you can get average value for the delta HM0. And what we found from the DSC curves, okay, that you have similar melting point, TM, of polyamide 6 were obtained for both samples of material with and without the polypropylene grafted maleic anhydride. Okay, this is with 7% short glass fiber. And here, that means that we don't have a big influence using the PP grafted maleic anhydride on the melting behavior. However, the PP grafted maleic anhydride increased the nucleating role of the short glass fiber by effectively dispersing the short glass fiber during the reactive compatibilization with the PEPP. And then you have subsequent homogeneous distribution, which increases the overall polymer filler interfacial area for nucleation, hence increasing the TMC or the matricization point, as we see here circled, of the polyamide 6 phase. Okay, so here you could see that it had a nucleating role rather than an effect on the melting temperature. Now, when we look at the effect of adding the glass fiber from 70 up to 40% glass fiber, we found that the maximum percentage of crystallinity was obtained in the pure PEPA composite. This is attributed to more overall restrictions in mobility. So mobility restrictions created by the glass fibers on the development of a spherulitic structure. So pure PEPA waste here had the highest crystallinity of 23%. And you can see here you have a decrease when you add more and more glass fiber. At 20% loading, the TMC or matricization of polyamide 6 is the highest, and the highest percent crystallinity is obtained for all the composites. And for short glass fiber content up to 20%, we have excellent dispersion and distribution of the glass fiber, and hence the glass fiber acts as efficient nucleating agents, yielding an increase in the TMC and percent crystallinity as the glass fiber content increases, due to the higher overall interfacial area with the polymer. However, interestingly, at 40% loading, the glass fibers start to form bundles because we have insufficient matrix materials, as shown by the SEM images, and hence we reduce our nucleating efficiency. So we have a lower TMC and lower XC or lower percent crystallization in our material. And incorporation of the glass fiber restricts the mobility of the PA6 chains, as evidenced by the higher melting point as well. So higher melting point, when we increase the glass fiber content, also shows the mobility, the hindrance, or the restriction in the polymer chain mobility, showing up as an increase in the melting point of the polymer. Now, we also did in our study torsional shear rheometry using parallel plate configuration at 230 degrees Celsius temperature and a low shear strain, keeping the shear strain at 1% to remain within the linear viscoelastic region. Okay, and we used a dye gap of around 25 millimeter. We found here that the addition of PP grafted maleic anhydride to the PEPA 7% glass fiber composites resulted in better dispersion and distribution, as shown by a steeper drop in the complex viscosity at low angular frequency or at low shear rate. So this kind of behavior, the steep drop, is due to increased particle-particle interactions, glass fiber interactions, increased polymer filler interactions, including hydrodynamic forces, as well as the polymer filler interfacial area interactions that result from higher overall interfacial area between the polymer and the filler. So this steep drop also reveals that we have a very strong matrix to fiber interfacial adhesion, as we saw in our SEM photographs. So furthermore, the increased overall polymer filler interfacial area interactions in the PEPA 7% short glass fiber composite with PP grafted maleic anhydride resulted in higher than imposed shear rate. So we caused a very high stress transfer, very efficient stress transfer between the filler and the polymer phase. And this resulted in basically more shear thinning behavior, as you can see by a steep drop of complex viscosity at high shear rates, due to the higher polymer filler orientation and earlier and enhanced shear thinning behavior at the higher shear rate. Now, when we increase our short glass fiber content going up to 40%, we saw that basically we have higher complex viscosity at the lower angular frequencies with higher filler loading level. And for PEPA short glass fiber 40% loaded composites with agglomeration, this increase is due to more particle-particle interactions, as well as due to agglomeration. More agglomeration means more particle-particle interactions. And basically what this does is it increases dramatically our complex viscosity. We also have higher polymer filler interactions, including hydrodynamic forces, but here we have to keep in mind that we're keeping the same amount or more of our targeted particle loading level. So the presence of a small amount of agglomerates, keeping the same amount or more of targeted particle loading level in the tested sample, could lead to a massive increase in the steady state shear viscosity of the composites. And the shear thinning behavior in the flow curves at the 40% loading is partially due to the orientation of the polymer and the short glass fiber filler, because we know that orientation of structures leads to shear thinning behavior, and also due to the disintegration of the glass fiber clusters. Now, when you look at the tensile testing of our injection molded bars, we found that the Young's modulus increased up to 30% glass fiber content, and then decreased slightly. And the same behavior was found for the tensile strength properties as well. So we had a linear increase and then a little bit of a decrease at the high loading levels. So what this says is that with the increase in the glass fiber content up to 20%, one can see the good dispersion and good distribution of the polar glass fiber and polar polyamide 6 inside the non-polar polyolefin material, polyolefin meaning polypropylene and polyethylene. And we have also good interfacial adhesion between the polar and non-polar parts. This implies a higher overall matrix fiber interfacial adhesion strength, and thus more effective stress transfer, which is the load transferring mechanism I mentioned earlier, and hence a stronger reinforcement or higher tensile and flexural strength and moduli up to 20% glass fiber loading. However, at higher loadings, higher than 20% glass fiber, more polypropylene grafted maleic anhydride is needed to maintain a higher overall PE plus PP matrix fiber interfacial area, and hence a higher overall adhesion strength, and thus more efficient stress transfer between the non-polar and polar phases. Because more than 20%, you see a very little increase, and then, as I said, at 40%, it even starts to decrease in the properties. Now, for the flexural strength and flexural modulus properties, we can see also the same kind of behavior, that at high loading levels, we start to see a decrease in the strength, flexural strength and flexural modulus properties, where here we did a 3-point bending test. And we found that the mechanical properties that were obtained from the flexural strength or flexural test were actually higher than those obtained from the tensile test. And this is due to the better orientation along the surfaces of the molded parts. So along where the molded parts the bars are basically subjected to high shearing. So at the edges of the bars, we have more orientation. And we know that in the 3-point bending test, if you have higher orientation, for instance, at the bottom of the bar of the glass fibers, what that means is that we have higher properties, higher mechanical properties at that part. And in the flexural test, we're concentrating our properties, we're measuring our properties at the part where you have high orientation in our skin core morphology structure. By skin core, meaning where we have high shearing imposed on the bars, we have high orientation. This is the high shearing is due to the mold, the mold plates that shear the glass fibers. And in the core, we have kind of like a perpendicular fountain flow of your glass fibers, where they are actually perpendicularly oriented to the direction of the flow. And finally, for our impact testing, as I said, because we have higher stiffness, more reinforcement, and that our critical length is our lengths of the glass fibers were measured above the critical length. So meaning we get very high reinforcement. We actually found that with increasing glass fiber content, we got lower and lower impact strength properties. And here, both impact strength and tensile elongation decreased with an increase in the fiber content. So this is due to many reasons, including the fact that as the fiber content increased, the matrix was insufficient to wet the fibers entirely, and this led to a poor overall interfacial bonding between the fibers and the matrix. So when the force is applied due to these voids, you have now weak points or stress concentrations. The composite has a tendency to fail rather than to elongate. We also have an embrittlement effect, as the ultimate tensile strength of the composites is improved when the fiber volume content is increased. And matrix crack formation exists at the ends of the reinforcing fibers. As the strain is increased, cracks form at the ends of the fibers, with shorter fibers yielding more cracks, because you have more, with shorter fibers, you have the presence of more fiber ends. So more ends with shorter fibers, and if you have longer fibers, you have a lower total amount of fiber ends. And also here, a higher quantity of fibers yields more cracks due to the presence of more fiber ends. So with more percentage of glass fiber, we have more fiber ends and hence lower impact strength. So to conclude, an innovative method was applied to successfully recycle difficult to recycle PEPA multi-layer food packaging waste by adding suitable coupling agent and short glass fibers as reinforcements using classical processes such as twin screw extrusion and injection molding to develop a novel composite material for different applications, including automotive, electronic applications, home appliances, toolboxes, and compost bins, for instance. And here we found that the best ratio of maleic anhydride grafted polypropylene random copolymer, or PP grafted maleic anhydride, to short glass fiber ratio, the best one was found to be 1:5 ratio to get the best properties. We also found that an effective reinforcement could be achieved with just 20% of short glass fiber. And based on this research, composites produced from recycled PP car bumper waste were then made with short glass fibers with optimized thermal and mechanical properties, and whereby the effects of glass fiber composition, length, as well as the type of coupling agents and the glass fiber polyethylene grafted maleic anhydride ratios were also thoroughly investigated. So here we did a publication with this as well as a publication we made on the PEPA glass fiber composites waste, using now car bumper waste, polypropylene car bumper waste, doing a similar kind of study, studying the different thermal, mechanical, and rheological behaviors of our composite materials. And with that, I would like to thank you for your attention, and just adding a comment by Albert Einstein: everything should be made as simple as possible, but not simpler, of course. And this is a quotation that I really like. And thank you for your attention, and I'm ready to take any questions that you might have. So any questions?
Thank you, Dr. Saif. Is anyone having any questions?
Okay.
I think there are no questions. Let's move to our next presentation. Thank you, Doctor, once again for your presence and presentation.
Thank you. Thank you. I hope it was clear and good for everyone, beneficial for everyone. Thank you.
Yep, thank you, Doctor. Our next presentation is by Dr. Syed Jalal from Alhme University, Iran. Doctor, are you ready with your presentation? Doctors?
Yes, hello.
Okay,
Yeah,
now I'm going to make you as a presenter now. Please share your screen.
Okay, thank you so much for your kindness. Excuse me, I can't see my page and my presentation.
You need to minimize that GoToMeetings app.
Okay, wait a few minutes. You share for me?
Sorry?
Wait a few minutes because I can see my page exactly.
Okay. Do you need to share our screen for your presentation?
I try to share my presentation.
Okay. Try once again. We can see your screen. Please click on that PDF. Yes, we
Okay,
can see your screen. Please continue.
thank you so much.
Thank you.
Hello, everyone. I'm Dr. Syed Jalaluddin Faraj, Assistant Professor at Allama Tabatabai University of Iran. I'm teaching urban management. My focus is on new concepts in field of cities. Some of concepts such as a smart city, creative city, flexible city, and so on. In this regard, if we want to have some relationship together, this is my way to connection. Exactly, this is my email and WhatsApp. Also, there is my phone number and ResearchGate. So today I'm gonna talking about a smart city. Exactly, most of my study is focused on smart cities. So in this regard, I have do some research such as the analysis of smart governance scenario of the urban culture in multicultural cities based on the concept of cultural intelligence and smart governance. It was published in the Springer journals, and the other one is infrastructure and strategies for launching camera-based smart parking in developing country, case study Iran. It was published in Italia. And other one is smart city ecosystem in developing country, and other one is smart parking and efficiency approach to city smart management and air pollution reduction. And something like this. Exactly, when I want talking about a smart city, maybe you have some question why we must study about this concept. As you know, the future of cities is have a relationship by the smartization. So if we want change our life, we must move to this side. So beside this research, I am focused on this topic, the role of managerial intelligence in shaping smart cities in developing countries. Exactly, my research is social research, and we are studying about a smart city by the social approach and not just managerial approach. You know, in our study, we believe a smart city is not just mathematical study. Exactly, we need to more know about social effect of the smart city, and also we must know how we can reach to a smart city and how we can launch a smart city in developing country. The role of managerial intelligence in shaping a smart city, in fact, have a relationship by the future of cities. Maybe when you look under this topic, you have some question about this. And I think the first question that comes to mind about this title of research and it's involved our mind is this question: what the future of cities will be like, and how will be future of cities? When we are going to talk about the future of cities, we must know some information about the future of cities. Exactly, we believe we are living a century known as the century of cities. The 21st century is the century of cities. I think we believe that the future of cities is main concept in human life. The population is set to increase by almost 700 million by the year 2030, reaching the total of 5.2 billion people. And this means that about 60% of the world population will live in the cities. So when we are going to talking about city, we are talking about the future of our life. This population growth will lead to many problems and issues. This population growth will cause to many problems. This issue need new and innovational solution to manage the complex life of today's city. So we will face a number of problems in cities in developing countries. When we look at the developing country, we can see many problems such as overcrowding place, horrific traffic, social cultural damage, poor green space, and wide range of problems facing urban management. And this is the big problem for us. For example, the issue of informal settlement, which is affected by the increasing population of cities, is some countries such as Egypt, Iraq, Turkey, Iran, and so on, or issue of population density in cities like Tehran, Ankara, Baghdad, Cairo, and the like have caused many problems for the citizens. Cultural conflict are another problem that is high problem for people and for manager. There are just a few of problem and issue that can be addressed in metropolitan of developing country. We have many problem in this kind of cities and these kind of countries. Beside the urban management and beside the urban plan problem, we have some problem about the manager and managerial study. Exactly, beside of this problem, attention to mismanagement and the weakness of managers is the administration of the cities creating many problems. For example, decisions that lack regular planning, decisions that are made with an emotional approach, or policies that are far from the reality of society, or weakness in the implement of policy, complex administrative bureaucracies, scientific weakness in the field of neo-urban concept, and so on. In the total, if we want to mention to the problem in the developing country, we can mention this kind of problem. urban problem and managerial problems. In the urban problem, we can mention to informal settlement, high density and social conflict, high traffic and air pollution, the unplanned growth of the city, sprawling urban growth, unbalanced urban development, weakness of technology, weak intelligence, and so on. And about managerial problem, weakness in evaluation, lack of comprehensive vision, spread management, complex bureaucracy, emotional function, information weakness, statistical weakness, and so on. So we have some question exactly. When we understand some of problem about urban problem and beside this managerial problem, now we are going to move to a smart city. How we can deal with these issues and these problems? What kind of plan can help us to improve the problems, and how we must manage this issue, and how we can move into smart cities? This is the main question that are using in urban management, because we believe future of cities will be a smart city. Future of city, we will create a new kind of city that we call it a smart city. Pay attention to new paradigm, and using them in urban environment can reduce some of the problem. In this regard, we can refer to some paradigms such as creative cities, flexible cities, smart cities, resilient cities, and so on and like this. Exactly, if we want to manage the future of life, we must move to the new ideas. In the meantime, considering the capability that a smart city have, the ability of this paradigm can be considered as one of the important paradigm. In fact, note to the increased growth of cities toward smartization has caused our focus in this research on the smart city paradigm. In addition to the smart city, we can also pay attention to capability of urban management. In fact, pay attention to managerial intelligence of each city authority can play an effective role in the future of cities. According to this study, we have considered and emphasized the concept of managerial intelligence to move into a smart city. So in this slide, I'm going to explain about the total of these two concepts. One is managerial intelligence, and other one is a smart city. Managerial intelligence is defined by three concepts: rational intelligence, emotional intelligence, and political intelligence. And a smart city is defined by 6 components, and this is a smart economy, a smart governance, a smart environment, a smart life, a smart citizen, and final, a smart transportation or a smart mobility. Managerial intelligence, we tell you, have a 3 part. Intelligent quotient or IQ, that is referred to individual's mental ability to think logical and solve problems. It encompasses logical reason ability and technical ability. Beside this, we have emotional intelligence. We call it EQ. The EQ refers to an individual's ability to manage one's emotion and others by arousing such feeling using empathy. EQ encompasses self-awareness, self-management, social awareness, and relationship management. And political intelligence is assumed as an activity ability to manage level of power and influence. Managers with high PQ level direct organization change. So beside the managerial intelligence, we are facing by a smart city. And a smart city is a framework primarily underpinned by information and communication technology to develop, expand, and promote sustainable development measures to deal with the growing challenge of urbanization. One of the most influential defense was provided by the University of Technology in Vienna in 2007. The smart city is a city that is well versed in forward-looking ways in the sixth component. I mentioned that in the last slide: smart people, intelligent mobility, smart governance, smart life, smart economy, and intelligent environments. In this slide, we can see some defense of this concept and this component. For example, I just explained for some of them, not all of them, because I think we must manage our time. A smart city or a smart people provide a high level of education for citizens and describe the quality of creativity. Or a smart economy is innovation approach to business, or intelligent mobility supporting more efficient transportation system and holding novel social attitude. Or a smart governance that have a relationship by the management and managerial people in the city. Or a smart life have a relationship by the quality of life. Or intelligent environment have a relationship by the quality of environment and a smart environment. So every component have a relationship by the smartization, and this is important to know for managers to how can move to the smart cities in developing country. In this research, we are studying this methodology. Exactly, this research is qualitative research. The library study and semi-structured interview were used to collect the required data. The statistical population was selected by the snowball sampling method. The thematical analysis technique was also used to analyze data extract from the interview with 14 academic and extractive experts. The collected data were classified and coded using the method. In the second phase, in vivo 12 Pro software was used to recode the data to increase the accuracy of the research work. Result of this method is more than 400 note, more than 90 basic theme, 16 organization theme, and final 3 main themes. Based on theme analysis method, we first interview the expert and gather data from the expert. In the next step, this interview will be organized by in vivo or MaxQ software. In the next step, it will be coded, and after this, exactly this is first part, is quantitative research. When we gather data, all of the data, and when we extract the code, start a new step. In the second step, we use some new method like Philadelphia, Topsys, VCore, or other statistical method and perform the final analysis. So this kind of research have a two part. In this first part, we gather qualitative data, and after that we use quantitative data and we manage this kind of data together. But in this research, we use the quantitative research exactly because the second time need more time, because in the social study, every study need more than 6 months or between 5 to 6 months to gather data, and this is get more time and need much time. Okay, according to last slide, I mentioned that the resulting is more than 400 nodes, more than 90 basic themes, 16 organization themes, and final 3 main themes. So in this slide, exactly you can see these codes. Exactly, managerial intelligence have a relationship by 3 main themes. We call it rational intelligence, emotional intelligence, and political intelligence. And these 3 have a relationship by 16 organization code. The first one, rational intelligence, have a relationship by making decisions, solving problem, strategic things, budget allocation, budget management, cost management. And in second one, EQ or emotional intelligence have a relationship by self-awareness, self-management, self-arousal, other awareness, other management, or emotional management. And PQ have a relationship about social games, power dynamics, political personality, transparent honesty, and controlling emotions. And final, these codes can have a relationship by a smart city and can help to management and managers to move city inside to the smart city. Exactly, if we want to explain the last slide, I want to tell you this is about IQ and smart city. In this slide, we can make relationship by each one of the concept. For example, In this slide, some of codes, the basic themes, they are managed in this row and is completely shown by this slide. You can show in this slide. Okay, I am going to explain some of them in this slide. In IQ study, exactly we reach this result: decision making, scheduling, budget, and final problem solving. For decision making, this term is a result of this kind of codes. So in vivo software, after we put the interview on the software gives us some main themes. The basic theme is this one. And after these basic themes, we can gather data in this kind of themes. We call it organization themes. In this organization themes, we can reach making rational decision about smart plans, for example, detecting a smart indicator of decision making, having creative in making decision, providing decision making for a stakeholder, and so on. Or in scheduling, the presenting key strategy to establish a smart city, operational plans for executive measure to the smart cities, presented strategy plans to enter electronic, or focus online on policy shaping and smart cities, and something like this. In budget, setting a necessity budget to foster creative urban idea, managing budget in promoting productivity by data, transparency of cost and revenue by adopting or observing justice in allocation funds, and something like that. Problem solving, the detection of problems play a key role in the environment's dynamics, providing solving to the problem with new idea. The selection of the best solution provided the ground for increased managers' connective capacity, and something like this. So in this kind of research, exactly in the quantitative research, we have a relationship more time by the themes, and we try to get some strategy from this kind of concept. In EQ also, we reach and extra some themes from the interview research, such as self-consciousness or scheduling or budgeting or something like this. And in the final one, in PQ and Smart City, we reach also some code and some themes from the software, and it managed in this table. You can see such as social games, power dynamics, political personality, and transparency, honesty. And everyone have a relationship by something like this. For example, in social games, we have a relationship by attracting citizen attention to accept relevant policies, or flexibility in different situation promotes management, or in power dynamics, we have a relationship by detecting power base and using them for the movement toward smart cities, and something like this. At final, I am going to tell you, when we gather all the data together, we can reach some data like this. If we are going to use managerial intelligence to reach to the smart city, we must careful about these three items. Exactly, about rational intelligence, emotional intelligence, and political intelligence. In rational intelligence, manager with emotional intelligence make the initial preparation in their mind. Focus on the individual is the base of emotional intelligence. In emotional intelligence, through political intelligence, managers provide the necessary grounds for implementation a smart city. In this intelligence, secondary dimension and beyond the individual are considered. And in third one, with logical intelligence, executive measure are take a launch a smart city. At final, if we want to reach to a smart city in developing country, we must focus on a manager person that have a relationship by three kind of ability. Exactly, the manager must be rational, must have a rational intelligence, emotional intelligence, and political intelligence. So this kind of ability can help to the manager to reach to a smart city. And I hope in the future, in developing country, the manager reach for this ability. Thank you for your consideration. If you have any question, I am glad to hear that.
Doctor, thank you, Doctor, for your presence and presentation. Is anyone having any questions? I think there are no questions. Thank you once again for your presence and presentation. Let's move to our next presentation by Dr. Ankush Ghosh from Nitoya University, India.
Thank you so
Dr.
much for your
Ravi.
kindness, and also thank you for everything. Exactly, I have tried to manage the time, because if I want to explain all of the sentence, I think it take much time. So I have tried to just explain some of the main part of my research, because I believe in this presentation we must exactly explain about my part of the study, know all of the studies. So I just mentioned some of the main concept of the research. Thank you so much.
Thank you. Dr. Ankush Ghosh, are you ready for the presentation?
Yes, thank you, Rachel.
Okay. Now I'm making you as a presenter now. Please share your screen.
Yeah, sure. Yeah, is it visible?
Yes, make it as a full screen.
Yeah, sure. Yeah. Is it changing the slides?
Yes.
Okay, thank you.
Thank you.
Thank you, Rachel. Thank you. Yeah. So I am Dr. Ankush Ghosh, Associate Professor of School of Engineering and Applied Sciences, the Newt University, India. So today I am going to talk about the hybrid spintronics and straintronics. So these spintronics and straintronics, straintronics is one type of spintronics, you can say, it's a new word, a new technology, we can say. So about going into the technology directly, it is spintronics. Basically, you can say it is a spin electronics. I'll be explaining some backgrounds of these for this technology, the path of innovation of this technology. Okay, so let's see the historical journey of semiconductors, or you can say electronics. We know the first transistor was invented in 1948, and then these MOS metal oxide semiconductor FET has been invented. Then a complete processor chip, and it has taken another 2 decades to develop. Then system, finally a system on chip, SoC kind of chip nowadays. So if we see the milestone of these IC industry, we have seen in 1947 these Burdin, Burton, and Shockley, they have invented the transistor. Then in 1958, Kilby invented these integrated circuit IC. Then in 1965, Moore's law came, and then in 1970, Intel introduced first 1 kilobyte of DRAM. Then in 1971, Intel announced the first microprocessor, 4-bit microprocessor. In 1976, Apple IBM PC has been developed. Then from 1995, Intel began to focusing on microprocessor product. And in 1991, ARM introduced its first embeddable RISC IP core processor. Then in 1996, Samsung integrated 1G DRAM. Then in 1999, SoC technology came. And in 2005, 4 processor, which contains 42 million of transistors. And these are the some of the breakthrough of these IC industry, IC manufacturing industry. And if we see the products of IC, almost all the electronics, home appliances and DSP-based products. So processor used there is basically an IC. Right? Other than these processor, memory chips, any analog devices like mobile communication, audio-video processing, programmable devices like PLA, FPGA, embedded system devices like network cards, as well as SoC system on chip. All these products uses the IC, integrated circuit, or IC chips. And if we see the Moore's law, Gordon Moore, one of the inventor of Intel, he has predicted a law, a statement which eventually we termed as Moore's law in 1965. He has predicted that the number of transistors integrated on a die would grow exponentially, and it will be double in every 12 to 18 months. And according to his statement, we have in 1980s the million transistor per chip barrier crossed, and today it is 55 billion 2 gigahertz clock in Intel P4, and 140 million transistor in HP PA8500. So as per his statement, which eventually called as Moore's law, it is the IC fabrication technology is continuously maintaining this statement, and it is according to Moore's law, we are means the number of transistors that have been integrated in a single chip is maintaining, like starting from with this 1965 to till date to the 2020. We can say up to Core i7, we are maintaining these number of transistor criteria. Yeah, here also it is showing the same thing. 1 billion transistor we have crossed. The 10 million transistor we have crossed. And here it is ITR's roadmap, where we can see we have already crossed these 10 nanometer barrier. Nowadays, the technologies that are used for manufacturing the processor, mainly computer processor or mobile processor or mobile phone processor, is using some 8 nanometer technology. So this 8 nanometer technology barrier we have already crossed. However, the problem is that near future we cannot go down infinitely, right? Though we have crossed this 10 nanometer technology, but we can go up to few nanometers of technology. We cannot go beyond 1 nanometer technology. Okay, so therefore there must be some different type of technologies or different type of thinking researchers should think, so that we can we can try to alive the Moore's law. We can try to maintain the Moore's law. Okay, so these are some of the limitations of VLSI technologies or sim VLSI CMOS technology. So therefore, this is one of the problem. Another challenge is these VLSI technology researchers are facing is that the power dissipation. If we see the present day transistor that dissipate around 0.1 to 1 microwatt of power per bit flip, for to switch on the device, we need around maximum 0.1 to 1 microwatt of power, right? So therefore, if we assume the transistor density is around 10 to the power 8 per centimeter square, which is the transistor density of Pentium 4, and so therefore the total chip is dissipating around 10 to 100 watt per centimeter square if all the transistors switch simultaneously, right? So now if we can make a chip size of around 10 centimeter square, that means 10 into 10 centimeter a chip, and let us suppose all the transistor of that chip power on switched on simultaneously, right? So therefore that if we calculate that the power dissipation for that particular operation, the power dissipation, the total power would be more than rocket nozzle. Okay, so therefore using our current heat sink technology, which is unmanageable, you cannot handle those that much of power, right? So therefore that is also threatens the Moore's law. Another third problem that we are facing as a VLSI engineer, VLSI researcher, that is the low power. Nowadays we are using these smartphone, any other than smartphone, also smart devices, smart wearable devices. we are using like smart watches. We are also using pacemaker. In satellite also we are using, satellite also there is a criteria of low power devices, right? So therefore, low power is one of the criteria that every day as VLSI engineer we are facing, right? So for all these reasons, researchers are proposing some new technologies that is totally different from current VLSI technologies. Okay, so basically for these three challenges like size limitations, like heat generation, as well as power dissipation. So what are those alternative technologies that can replace these whole VLSI CMOS technology? So there is a list of technologies that researchers are doing research on, like resonant tunneling diode (RTD), like single electron devices, ACD, carbon nanotubes, rapid single flux quantum (RSFQ), silicon nanowire, silicon quantum dot cellular automata, that is QCA, single electron transistor, and magnetic spin devices. Okay. So these are the entirely new technologies for next generation electronics, but unfortunately, none of these technologies has, till date succeeded in replacing the conventional silicon transistor, because the existing material and fabrication technologies are, beyond beyond our realistic. Um, so therefore, therefore, except some of these technologies like resonant tunneling devices, all the technologies are restricted to operate below the room temperature, and therefore, which means these technologies cannot be used for real life application as of now, right? So, so therefore, one of the new technologies that we are thinking to overcome this hurdle is called spintronics. So this is a novel technology. It has been proposed by Professor Supriyo Datta and Vishwajit Das from Purdue University in 1990s. Their first in the first paper they called is spintronic analog of electro-optic modulator. So what they have proposed? They have proposed that combining these spin, that is an extra degree of freedom of that offered by a magnetic material, and the versatility of active semiconductors are anticipated into non-volatile, versatile, fast, and capable of simultaneous data storage as well as processing while consuming less energy. Okay, so what is their spin electromodulator? Let us see. I'll show you the spin electromodulator. But before that, there is a history showing that in using the spin, spin electron technology, in 1980s, one of the discovery has come, that is in giant magnetoresistance (GMR), which also uses that same kind of technologies. Like they are also using spin as extra degree of freedom, and using spin they can encode encode the data like 1 and 0, the binary data in parallel and anti-parallel spin, and using these encoding these parallel and anti-parallel spin of data, that is 1 and 0, they are they are using to store the data into devices basically called hard disk, and it is called spin hard disk. So that has been discovered, that has been used. However, The problem with these spin-based FET or MOSFET is that it is not that that large devices. It is a nanometer size of devices. So that is the challenge, to encode and to control the spin into that nanometer size of devices. Right. So this is the famous the transistor. What they have proposed in this paper of APL, Applied Physics later in 1990s, that they have called it a spin transistor modulator, and there is a source and a drain, and in between they made a channel which is of indium aluminum arsenide or indium gallium arsenide. Basically they proposed the two-dimensional electron transport from source to drain via this channel, and what they have proposed, they are sending these electron with a particular spin orientations, and when they collect these electrons in the drain end, they are detecting the orientation of the spin. Right. Now let us suppose all these electrons from the source end, they have oriented as upspin, and it is detected as upspin in the drain. So this is this is, you can say, a direct communication from source to drain, and what they are changing, the output is basically they are trying to disturb these spin of the electron using these gate voltage, just like other MOSFETs. They are using these gate voltage to disturb the spin of these electrons, spin orientation of these electrons, and therefore let us suppose the electrons are coming with upspin from the source terminal, and due to some disturbance, the spin orientation of those electrons may change, and in the drain end, it can get the spin with downside orientation, which may be denoted as 0. So therefore, this can be used as NOT gate. So like these, they have proposed. Now the problem with these kind of technology or this kind of proposal is that the electrons still physically moving from source end to drain end, right? And our main motto is to objective is to cut down these channel length, right? So if the channel length is cut down, it is basically called scaling, and therefore we can make faster devices. So the power power consumptions may be reduced, the heat generation may be reduced through these. However, the thing is that still here in this case, the electrons are physically moving from source end to drain end. So to overcome these, therefore the same challenges, that is heat generation challenges as well as power consumption challenges applies here, right? So to overcome these challenges, in 1994, again, sorry, in 1994, Professor Supriya Bandyopadhyay of Virginia Commonwealth University, they have proposed a new technology named as single spin logic technology, or SSL. So what is that? So before going to that, I should explain these using these Dr. Das transistor technology. They have called it spintronics, that is electron spins are used, spin plus electronics, that is spintronics. It is not charge based electronics, and some of the applications of these like spin fed, what they have used here. And in MRAM, magnetic spin RAM also used. In GMR, magnetic hard disk also, this type of technologies are used. However, as we are discussing, still they have the problem, the challenges, like still electrons are moving from source end to drain end. Physically movement is there, so therefore obviously there should be some heat generation as well as power consumption issue should be there. So to overcome these technologies, spintronic technology, spin logic technology has been developed by Professor Supriya Bandyopadhyay, Virginia Commonwealth University in 1994. So what they have proposed? They have proposed single electron that is confined in a qubit. So how to confine the single electron in a qubit? They have proposed a 5-layer technology. This is they have named as pentalayer technologies. Okay, where base layer is ferromagnetic, then insulator layer is there, and some semiconductor, and the electron is basically trapped in between this Schottky metal gate. Okay, so they named it single spin logic technology. What happened? These electrons are bistable direction, means it can the spin direction of these electron can be either upward direction or can be in downward direction, right? So these spin the flip the spin of these electron can flip by upward as well as downward. And when there is no current flow, no spin will flip. And if there is current flow, then electron will flip. And yeah, this is the paper that nanotechnology in 1994 they have developed. Professor Supriya Bandyopadhyay, B. Das, and A. Miller in nanotechnology. They have first proposed these technology, single spin tonic technology. So what happened here, as per the law of the spin, electron spin, if the two electrons are, these two are neighboring electrons, and if one of these electrons are oriented as upward spin, so the second electron must be in downward spin, right? So therefore, if we can encode these as input and we can encode these as output, so what happened? These should be behaved as a NOT gate, right? Because if it is upward direction, it should be downward. If it is downward direction, it should be in upward. And if we can encode this upward and downward direction of electron spin as the the binary number, that is 1 and 0. So basically, if it is 1, it will be 0. If it is 0, it will be 1. So basically, this is behaving as NOT gate. And you can see there is no physical movement are required, right? So information is passing from input to output without any physical movement of electron. So that is a wonderful idea, and therefore if there is no physical movement of electron, there will be no no heat generation, right? So therefore the heat generation problem will automatically resolve, as well as if we have to just change the orientation of the electron spin, not we have to send physically the electron. So therefore the power consumption is also very low. So this is the concept of these spintronics or single spin logic, or we can say hybrid spintronics here. So therefore, this is another concept of NOT gate. This is the concept of NAND gate, basic universal gate, where you can see these two sides are two inputs, and this one is the output. Okay. Now, if both of these input is 0, the output should be in upward direction. That means 1. That means the NAND gate truth table 0 0 is 1, and also as per the NAND gate 1 1 is 0. So if the both of these inputs are in one direction, this should be in downward direction. That means 1 1 0. Now the problem will arrive when if one of these input is upward direction and one of these input is downward direction. So what happened? The output may be 1 or maybe 0, because it's one of its neighbor is in upward direction, one of another neighbor is in downward direction. Right. So to solve these issue, what they have proposed a global magnetic field which must be in a particular direction. Okay, so let us suppose here the global magnetic field is in upward direction. Okay, so therefore the output should be in upward direction. That means 1. So this way we can solve the issue. Means if there is a confusion, one of these input is downward and one of the input is upward direction, so it will follow these output will follow the direction of global magnetic field. So this way we can solve this issue. They can solve this issue, and they can so this way they have proposed these universal NAND gate. You can see the 0 0 the output is 1, and the 1 1 the output is 0. And if one of these input is 0, one of these input is 1, so what happened? Since the global magnetic field is in upward direction, it should be in upward direction. And similarly, if one of these in upward direction, one of these is downward direction, that means 1 0, it should follow the global magnetic field direction of the global magnetic field, that is in upward direction. So thus these the truth table of these NOT gate is valid. And if we can fabricate the NAND gate, we know NAND gate is a universal gate. So in any and every kind of digital circuit can be implemented through this universal gate. So therefore these fabrication issues have been solved using this. And this has been this picture has been taken from MIT of Professor Caroline Ross. They have fabricated those nanomagnets. So these are the figure of single domain state of magnetization. Okay. Now, what is our future scope is that we are trying to make these since this is a very low power consuming devices. So therefore, if we can harvest the energy from the environment, we can we can run the devices with that energy. Okay, since it needs very microwatt or nanowatt power of energy to run the devices, so therefore you can use some energy from the environment. So how to get the energy from the environment? We have a very low cost solutions. The solutions like piezoelectric is a very low cost solutions. If we can use these piezoelectric also generates energy from the nature, and if you can think of the applications like the pacemaker that can be put in the heart of a human being, And whenever the human being is moving, from the movement of this human being, it can generate the power, it can generate the energy, and that power can be fed to these devices in the electron devices. And this way we can solve the battery problem. And even we do not need of any battery for the pacemaker, for the space, any devices that can be used in the space. So this type of problem can be resolved using this technology. So therefore, these technology we have named these as straintronics, since the strain, if the strain is applied and energy is generated, power is generated, and that power is fed to the devices. So therefore the name has been changed, the nomenclature also changed from spintronics to straintronics. So this is the concept of straintronics, where a nanomagnet dipole couple logic has been used, and unlike single electron, here the magnet's magnetizations is used. Okay, and it is shaped as elliptical shaped, and just like the single spin logic that we have mentioned there, the same logic is applied. Like here you can see the downward spin, and it upward spin. So unlike the single electron confined in a qubit, we are using these as a nanomagnet. Okay. So this type of these nanomagnet concept that has been proposed in 1999. And in 2007 also, Salahuddin, they have worked on these kind of nanomagnetic devices. So therefore, in case of these nanomagnetic straintronics, also same kind of logic applies, where you can see these two inputs. If the two inputs are downward direction, output should be in upward. Similarly, if 2 is upward, the out is downward direction. And the same problem arises if one of the input is upward direction, one of the input is downward direction. What happens? It will follow the global magnetic field direction. So therefore, in both the cases, it is in upward direction, and therefore it follows the truth table of NAND gate. Here we have encoded 1 as upward direction and 0 as downward direction. So here you can see the comparison of shape and energy and dipole interaction energy. So so here you can see the energy required to change. It is maximum energy required to change is in 90 degree, so which is very unstable state. Therefore, the stable state is either 0 or in 180 degree. So that means either in upward direction and another is in downward direction. Okay. Now this is the mechanism how these stentronics are used as a switch, and we can see there is a very we are using these structure for making these nanomagnets. That is a piezoelectric structures are used with magnetoresistive layer. 40 nanometer of piezoelectric with 6 nanometer of magnetoresistive layer has been used, and across these the battery terminals we provide the power. This can be flipped, right? So therefore it has the capacity of operation in room temperature, and the energy dissipation you can see around 160 kT, which is in sub nanoseconds with 99.999% switching probability and room temperature, and the error probability is very less, 10 to the power minus 6 times. Right. So it is extremely energy efficient, we can say. The piezoelectric material basically used to manufacture these devices and to fabricate these devices. The piezoelectric material that we have used is PZT and PMNPT also we have used. We have also used in some papers like Tafenol D. So because these are the ferromagnetic material and has a good spin coefficient. Right. So this has been we have received these one of from our collaborator Professor Bandyopadhyay from Virginia Commonwealth University. In their lab they have fabricated these nanomagnets, and these are the pictures. This is an unpublished pictures, and this is on PMNPT they have fabricated. So these are the references that we have used before going to the questions. These are some of the international journals that we have published using these for these single spintronics, stentronics, and in the field of hybrid stentronics as well as hybrid spintronics as well as stentronics. So thank you. If you have any questions, I'm ready to answer.
Thank you, Dr. Ankush Ghosh. Is anyone having any questions? I think there are no questions. Let's move to our next presentation. Thank you, Doctor, once again for your presence and presentation. Our next presentation will be by Dr. Octavie from the Université des Sciences et Techniques de Moscou, Gabon. Doctor, are you ready with your presentation?
Thank you, Rachel. Also,
thank you, Doctor. Dr. Octavie, can you hear me?
Yes,
I made you as a presenter now. Please share your screen.
Yes, I'm ready.
Please share your screen.
Everything is okay?
Yes, it's perfect now. You can.
Okay, thank you, everybody. My name is Octave Mutsinga. I am from University of Science and Technology of Masuku. Masuku has two names. Masuku is also called Franceville in Gabon. The title of my talk is Dead Particles into Bubbles Turbulence. And my aim is to give a stochastic properties. First, I will introduce the problem by showing first the Navier-Stokes equation, and then show that Berger's equation is a simplified form of this. I will show the link with Berger's equation, and I will give the main properties of the stick particles dynamics. When I'll give some stochastic properties of tagged particles in fluid turbulence. This is the so-called Navier-Stokes equation, where rho is the density of mass per volume, capital V is the velocity field, nabla is the gradient operator, here rho g is the weight of a fluid particle, P is the pressure. This part is concerned with the viscosity, and this other part is concerned with the electric and the electric activity, electric and magnetic activity. Simplified form gives the so-called Bettman-Berger's equation here. This form is in one dimension. When sigma equals 0, we call this equation the inviscid Berger's equation. Now I will show that before showing that the equation, because before showing the link with sticky particles, I will explain first what is the sticky particles dynamics. This model was first introduced by Zodovich. In the discrete case, you consider n a finite number of particles on the real line, but they can be also on dimension 2, 3, or more. Here we concentrate on dimension 1. Each particle is characterized by its initial position xi, its initial velocity vi, and initial mass mi. While there is no collision, the particles move with constant velocities. All the shocks are completely inelastic, and the dynamics goes on following the laws of conservation of mass and momentum. How can we define sticky particles dynamics in a fluid, since in a fluid the set of particles is not discrete? We need, before which I show you the dynamics. Before the shock, we can tag a particle by its initial position xi, and this particle at before shock has the position at time t xi plus t times the velocity. The velocity at time t is conserved, as well as the mass before the shock. In case of shock, the tagged particle xi belongs to a cluster, and the mass of this cluster, or the mass, say the mass of the TED particle, is the mass of the whole cluster, and you take into account all the particles that are concerned in the shock. The velocity is given here, anyone can see that this corresponds to the conservation of momentum, and the position of that particles of the particle xi at time t is given by this mean, and you can get easily all these formulas by a recurrence on the shock times. Well, I was saying that we need now to construct the dynamics and the non-discrete case. In order to do this, you need non-negative measure, say mu 0, which is finite and compact subset, which means that in a compact subset, the mass of the matter is finite. You also need a velocity function, a function u0, which is Borel function, which is locally integrable with respect to mu0. And we need also a regularization condition, which means that particles which are distant cannot enter in collision in a finite time. For example, in the last case of discrete sticky particles, mu0 is a combination of Dirac measures weighted with masses mj, and the velocity function of TED particle xi is vi. Now, if in the non-discrete case, the interval AB is a cluster, I mean the set of all step particles at time t, then for only TED particle y belonging to the cluster, the mass at time t will be computed as follows, taking the measure of the whole cluster. The position of TED particle will be given by taking this mean, and the velocity by this other mean, and this allows to define a new function ut on the position x at time t of the TED particle y, and a new measure mu t, giving the mass of a new state of a particle at time t. An interesting property is that at time s, the measure mu s and the function us satisfy the requirements which allow to construct a new sticky particles dynamics. Then which is the link between the sticky particles constructed from time 0 and the one constructed from time S. The length is as follows. Consider a function which starting from time S gives the positions of a new dynamics. This function has what we call a forward flow property. This means that if you take a charged particle y, if you look at its position starting from time 0 to time s, then you take again a new time t after time s, and you take the new position in this new dynamics, then it is the same thing as starting from 0 with charged particle y and letting the time go until s plus t. We call this the forward flow property. There are other several properties. Consider that x is a position of some cluster at time t. Define the cluster of initial charged particles, which has position x at time t like this. And you get important properties which are the same already obtained by some authors like Ersenay, Rikoff, and Grenier and others. And another property which is inherited by the fact that when you have a cluster and you divide the cluster in two blocks, it's the position, the new position of this block acts as if the block on the left is now at time t on the right of a block that was on the right. These properties lead to the trajectories of the endpoints of a cluster. We get that for the left endpoint of a cluster, its trajectory is a concave function of time until it is hidden from its left. Analog for the right endpoint of a cluster, it is a convex function of time until it is hidden from the right. This is the degenerated case where the position x, the new position x, is an accumulation of matter from the left. It gives that the concave function is a straight line. Analog for the right endpoint of a cluster, if x is an accumulation from the right of matter, then the convex function is a straight line. This will be illustrated later. This is another important property, which means that the restriction of the dynamics on a compact subset of space-time does not depend on the whole matter, but only on the matter concentrated in a compact subset. Now, which is, before going further, which is the link with the implicit Burger's equation of initial data U0. I stated in previous works that when the mass is distributed following lambda the Lebesgue measure, then the function u, which is the solution of the implicit Burger's equation, is also the velocity field of the sticky particles. And a distribution of mass at time t is given by lambda minus t times this measure associated to the function u again. And the meaning was this is the measure, the so-called measure of Lebesgue stilges associated to the function u. The definition is this one. For example, if a function f is a repetition function of some probability p, then the associated measure is exactly the probability p. Second case of sticky particles, which is related to Burger's equation. Take the initial luminosity U0 non-increasing and take the Lebesgue measure associated to minus U0 as initial mass distribution. Then again, the solution of the implicit Burger's equation, U, is the velocity field of this system of sticky particles, and the mass at time t is given by the opposite of the Lebesgue stilges measure associated to minus u. So everything I can say here according to sticky particles is will hold in the case of Burger's equation, the implicit Burger's equation. Now, when you take at random a tagged initial particle, consider its position as time t, like this, which is also a random variable. And now we have a stochastic process. We can define the sigma field associated to this process like this. This is a filtration, which is non-increasing. When we get that, the time derivative of this stochastic process is the function u, which confirms that the time derivative of trajectory is the velocity, provided the law of x0 is the initial distribution of the mass mu0. The forward flow property reads here, which means that the process x is a Markov process. Moreover, the conservation of mass and momentum, remember that we had some expectation knowing the position, but then this first property reads as follows, which means that the velocity process of that particle is a martingale, but in a backward sense. Now let's go to turbulence. We were inspired by the ideas of Inc and Rivas. We wanted to understand the turbulence trajectories. They decided to consider the first time where the tagged particle A enters in a shock. Here, we define a turbulent interval, the turbulent interval of A, as the interval denoted as follows: of all the tagged particles A prime, in which belongs A, and on which the function tau is constant. This means that this interval is the set of all tagged particles which enter in turbulence at the same time as A. In fact, the time tau is more related to turbulence than to the idea of shock. In these examples, you can see that if you take at random this initial tagged particle, say this is little a, then the turbulent interval is the interval AB that you can see here, which enters in turbulence at position X at the same time for any particle belonging to this interval. And here there is a real shock in the sense that many particles enter in a shock. In this case, we have nearly the same case, but the turbulent interval enters in turbulence at position X, but the turbulence began earlier from this other turbulent interval. In this last case, we have that A equal B equal X0, which means that when the turbulence occurs, there is no shock, but at position X, there is a beginning of a coagulation process. This is the case where the idea of shock is not the same as the idea of turbulence. Now we can see what I have said before. This is a position of shock, and this is the left endpoint of the cluster. This is the right endpoint of a cluster, which is in the shock, in this shock. Where there is a vacuum initially of matter here, the trajectory of this endpoint, of course, I didn't say it before, but in ordinate, you have the time axis, and abscissas, you have the initial state abscissa, initial state. So this is a concave function of time, and this is a convex function of time. As you can see, this is like a butterfly with folded wings. That is why I call this butterfly shock. But here you have what is often known as a delta shock. So in a butterfly shock, you have many delta shocks, which are delta turbulent shock. Now we can define random objects. Gamma, the time of turbulence of random particle, random typed particle X0. Z01 is like this. Z01 is the left endpoint of turbulent interval. Z02 is the right endpoint of turbulent interval. Z03 is the initial tagged, the left extreme point of the cluster, and Z0 cast is the right endpoint of the cluster. The cluster which has turbulence time gamma at this position. Now you consider the trajectories, which are illustrated, of course, here. Blue one trajectory is the one of Z3. Blue one here is the one of Z4. When X0 is here, the green one is the one of Z1, and the red one is the trajectory, straight lines here of Z2. You have, of course, that the time derivative of any trajectory corresponds to the velocity process u on the trajectory. You have a Markov property inherited from the forward flow property. But here, contrary to the previous case, the velocity process along these new trajectories are not necessarily martingales, but they are semi-martingales. Semi-martingales of bounded marginal part given by this formula. The only way to have a martingale is that the process considered is indistinguishable of the process X. In this case, any turbulent interval is reduced to a single point. Well, I think I will finish. I will end here, and I thank you very much for your attention.
Thank you, Dr. Ottovi. Is anyone having any questions? I think there are no questions. Let's move to our next presentation by Dr. Mohammad Farhan from the
Thank you very
University of
much.
Hong Kong. Yeah, thank you, Doctor, from Hong Kong. But due to some emergency, he was unable to attend today's webinar, but he has provided his recorded video presentation that will be presenting from our end. If you have any queries, you can mail to the concerned program manager. They'll respond.
At the University of Hong Kong under the supervision of Professor Dr. Chen Fei Zhang. The main contents of my presentation will be the introduction, biofunctional molecular functional tension probes, cellular imaging, and summary. So first I introduce my topic. I discuss a recent reports that use DNA-based nanomaterials for plasmonic imaging, and they attach the gold nanoparticles of various sizes at specific positions on a 2D DNA lattice, and the spatiotemporal changes in the positions of the gold nanoparticles were imaged because the electronic cloud around gold nanoparticle experience some resonance if the gold nanoparticles are packed within very narrow spaces. And DNA is a material that can keep them at the specific distances. So we can design the DNA-based material and the specific and functionalize these materials with the gold nanoparticles with the specific distance. And this is possible only with the DNA-based nanomaterials. Other material, we cannot get spatiotemporal specificity in nanoscale precisions. This is another recent report, and they polymerized some DNA tiles into 2D lattices. The 2D lattice can be either the nanosheet form or the fold onto itself, and then can make a nanotube structure. I also reported some DNA, 2D and 3D DNA materials before. And this recent paper shows the functionalization, the ligand functionalization of the 2D DNA lattice, and can interact with the multiple cellular biomarkers for bioimaging. And this report also functionalized the 2D DNA nanosheet with some biological compounds for immunotherapy. So, as my focus on in this presentation is molecular tension probes for bioimaging, so I will discuss two main types of molecular tension probes. First is surface fixed probe, and the second are non-surface fixed probes, or the free probes that can interact with the cells. The surface fixed probes are fixed to the surfaces and interact with the cells and either they produce some fluorescent signals or they produce change in plasmon coupling, because the gold nanoparticles have electronic clouds, and in dark field we can see the spectral changes in the gold nanoparticles. So non-surface probes are free probes, and the simplest probe can be the hairpin structure that can interact with the receptors, and when they are internalized into the cells along with the receptors, and then they are unfolded, the hairpins are unfolded and fluorescence is produced. And also they can be used for intracellular imaging, because the intracellular imaging is also important for studying cancer, to study the metastasis. And the bispecific activations, this report was the first report that used 3D DNA nanomaterial to act on the two different cell receptors at the same time and produce some fluorescent signals for bioimaging. For my case, I also used some plasmonic nanomaterials when I used gold nanoparticles in the close vicinity, and when the cells exert force on the gold nanoparticles, the spectral shift occurs, and also the distance between the gold nanoparticle changes. And I studied different cellular events with the live cell imaging with the dark field microscopy, so like cell attachment, detachments, exocytosis processes, endocytosis processes, cell divisions, and internalization of DNA probe as well as the receptors. So these studies are good for bioimaging, the plasmonic imaging that can measure the spectral shifts between the gold nanoparticles, and also can image the cellular events going on the cell membrane. This was a study published in 2018, and they showed some videos to image the cells, the mechanical processes of the cells, cell contractions, etc. And this video I took during my experiments, also showing the dynamic changes on the cell membranes. So we can see the interaction of the DNA device with the cell membrane, and we can also see the internalizations, cell internalization, which we call endocytosis, and also the cell contractions. So the objective of our study was mono bio tri-specific activation on cancer cells, enhanced cytoskeletal activation, and imaging biophysical cell events. So purpose and innovation. Purpose was to didn't study the effects of different receptors on cellular processes simultaneously, and we imaged that interactions between the cell surface receptors because many cell processes are involved with more than one type of receptors. So it was important, and I used short circular scaffolding technique. So this technique gives the stiff structures and can be used for intermolecular interactions and multi-ligand functionalization, and we can target multiple receptors on the cells. Now I will discuss the design, synthesis, and characterization of the molecular tension probes. As we can see, my DNA probe had two anchor strands with the gold nanoparticles, and the gold nanoparticles got coated with a ligand, for example EGF, that could interact with the EGF dimer, and the side chain had aptamer that could interact with the integrin alpha 6 beta 4, and also had some gold nanoparticle here. And the hairpin structure, when the hairpin structure was unfolded, the distance between the gold nanoparticles was changed. So how I synthesized, I used the short circular scaffolding technique to make the rigid rectangular structure for my DNA probe using different hairpin structures. I can program this portion, and the longer hairpin will require greater force to unfold the hairpin, and the shorter hairpins will require less force to unfold this side arm, and also depend on the nucleotide sequence. For example, GC has triple hydrogen bonding, so require more force to unfold, and AT has double hydrogen bonding that can be unfolded with this smaller force. So characterization, I did some UV and some hyperspectral imaging, and also the TEM and some gel characterizations, and also the unfolding of hairpin, study of the unfolding of the hairpin structures. And this is the mechanism actually when this probe interact with the two different types of receptors, for example EGFR dimer and integrin, then it stabilizes on the cell membrane for 35 to 45 minutes and activate different biochemical events to produce the mechanosensitization of the cells and activate the cytoskeleton for cell contractions. But if we only activate the EGFR, then it is quickly internalized into the cells, because the EGFR after activation is quickly internalized into the cells to cause the cell proliferations. But in our case, the DNA probe was stabilized on the membrane for 35 to 45 minutes, and we were able to image the cellular events occurring on the cell membrane. So the binding of the probe to the cell membrane was a desirable event for us for bioimaging. And we were able to image the probe on the cell membrane, while the control probe showed the signals throughout the cells, and we were able to image the cell membrane, the dynamic changes in the cell membrane. And there was a report in 2009 that also reported some gold nanoparticles to be interact with EGFR and internalized into the cells and producing intense fluorescent signals inside the cell. But this paper failed to monitor the dynamic changes on the cell membrane. So our study enabled us to monitor the dynamic changes on the cell membrane. So our DNA probe was resided on the cell membrane, and the control probe was quickly internalized into the cells. And we can clearly see the philopodia extensions after the activation of cytoskeleton compared to the control after we add our deep probe. And also the previous reports that used only integrin to activate also showed some extension in the philopodia of the cells. That was our results are correlate with these results. And for studying the hairpin effect of the hairpin structure, we use different length and sequences, and we can see if more force is required, then the fluorescent signals become dimmer if we increase the GC contents. And if we increase the GC contents to 100%, the fluorescent signals are decreased. And if we study the cytoskeletal activations, then we can use the FEDC loaded rho kinase binder, and we can see the green signals that shows increased cytoskeletal activity. If there is more activity, like if both receptors were activated simultaneously, so it shows the interaction between the receptors and produces more cytoskeletal activation and more force the cell exerts on the cell surface. And this force that shows in black, when both receptors are activated, then the force is increased. We can see the protein expression with both receptors activated, that more protein expression we can see. Means these proteins are for the expression of that shows the cytoskeletal activations, and they are more. The cytoskeletal activation is more when both receptors are activated simultaneously. But after 1.5 hour, the cells are exhausted, and the cells who are under mechanical stimulations are exhausted and dead quickly than the control. So the cytoskeletal activation also produces some exhaustion effect to kill the cells. So this new method to kill the cell is called mechanopharmacology. And we can see if we tag the anchor strand with some fluorophore like cyan fluorescent protein, and we can still like image the dynamic changes in the cell membrane. So this is related with the previous experiments, and we can also measure the force and stress on the cells through this method. We also studied the cell proliferation at different time intervals, and we can see in the start, like 30 minutes, the cell proliferation increased due to the mechanostimulations of the cells, but later, due to the exhaustion effects, the cells started to apoptose. So the summary of this presentation is in vitro imaging of mechanical cellular processes through the change in plasmon coupling and fluorescence. Co-activations of EGFR integrin by DNA probe stimulated enhanced cytocellular activation and calculation of equimotor forces promoting the mechanical cell processes. And we were able to track cell contractions, dynamic changes in morphology, and different cellular events like attachment, detachment, invariant motility, metastasis, and cell signaling, and increased mechanical activity and repeated containerization of receptors and degradation by the lysosome cause cell death due to the exhaustion effect. And this new way to kill the cells is called mechanopharmacology. So thank you, everyone.
Thank you, Dr. Maria Farran. Is anyone having any questions? You can mail to the concerned program manager. They'll respond. Our next presentation will be by Dr. Kaku and Divya Priya. Due to some emergency, they are unable to attend today's webinar. So by this, we came to our day 2 webinar. I would like to thank all the attendees and participants of today's webinar. Hope you enjoyed the webinar and gain knowledge from these sessions. If you have any queries, you can mail to the concerned program manager, and we'll be glad if you could join us in next webinar, which is scheduled, and the dates will be announced to you by mail. We'll be very happy if you could share us your opinion and feedback with us. Thank you once again for your presence and presentations. Thank you.